네, 안녕하십니까. 네, KYPT 2020 결승전을 이제 곧 시작하도록 하겠습니다. 우선 결승전에 앞서 어제 이제 저희 사무국의 그 집계 오류로 인하여 순위 변동이 있었고, 그러한 과정에서 이제 여러 학생분들과 학부모들께 심려를 끼쳐드린 것들은 정말 진심으로 사과를 드리도록 하겠습니다. 하지만 저희 조직위원회는 더욱더 공정하고 신뢰성 있는 대회를 운영하기 위해서 최선을 다해서 노력할 터이니 이러한 마음의 어떤 짐들은 다 벗고 어그로 양해해 주셨으면 좋겠습니다. 네, 아무튼 이러한 집계 오류라는 그 실수에 대해서는 제가 또 전체 조직위원회를 대표해 사과드리겠습니다. 그러면 이제 그 마지막 결승전 이제 시작하도록 하겠습니다.
Okay, we'll get the final of the 19th KYPT, and let's start with the team captains introducing yourself and your team, and we'll start with the reporter team.
Hello, ladies and gentlemen, we're Team Frisbee from Economy, Science and Earth. I'm the captain of Team Frisbee, Wonson Lee, and here's my members: Suhyun Lim, Kyuhyun Jang, Chun Sung Park, and Edward Choi. So we thank the great honors first grade KYPT 2020 final stage, and we hope to have a great time with full of interesting, amazing, and mysterious physics phenomena. Thank you.
And the opponent team captain.
Hello, my name is Wonjun Kim from Team Hamler Senior, and our teammates are Song Sang-hyuk, Itaeung, Choi Jung-kyung, and Dong Ji-won. And our experience in past 4 physics fight was the best and the happiest moment in our life. And let's continue the happiest moments until the end of the competition. Thanks.
Hello, ladies and gentlemen. I'm Yun-Kyu Lee. I'm captain of team format of Hana Kim Seoul. And from my left, this is Wan Young-han, Lee-Soo Hong, Subin Lee, and Young Lee. And we hope to have a meaningful peer review session and a good PF. Thank you.
I would usually ask the jurors to introduce themselves, but for sake of time and number of jurors, I'll just, on behalf of the jurors, we wish you good luck. And so let's start with the opponent team. I guess the problems are all determined already, so reporter team, you have the stage when you're ready.
Sorry to keep you waiting. Now I'll start my presentation on problem 17, playing cards. Thank you. Good morning, ladies and gentlemen. I'm Suhyun Lim from Team Frisbee, and I'm here to present about problem 17, playing cards. This is the table of contents. Let's first look at the problem. Problem 17, playing card, states a standard playing card can travel a very long distance, provided that spin is imparted as it is thrown. The problem states to investigate the parameters that affect distance and the trajectory. So let's look at the phenomenon. As you can see, when a spin is imparted on the card follows a certain trajectory and it flies longer than when a card is thrown without any spin, which in that case, the card will tumble to the ground. From this phenomenon, there arose the need to analyze the motion of the card in detail. So to do that, we devised a preliminary experiment to do a more detailed analysis of the card's movement. We used 2 high-speed cameras, one facing the floor and one facing a wall perpendicular to the floor, and took high-speed camera footage of the card's motion in flight like this. And this. To do a more detailed analysis of the card's movement, we set 3 points on the card to more accurately track the card's movement. There is the point A and point B, which are the 2 corners of the card, and there is a point for the center of mass. So by tracking the 3 points movement, we could track the entire motion of the entire card. The left plot is the motion of the card tracked from the floor facing camera. You can see that points A and B rotate around the center of mass as the card flies. From this, we can infer that the card rotates around the center of mass as it flies. The right plot is the card's motion viewed with the wall facing camera. You can see that the trajectory of the card is curved. And then there is tilting or the marker separation. We first have to define what marker separation is. Marker separation is the distance between point A and the center of mass projected onto a plane that is parallel to the plane that the camera is viewing. The left plot is the marker separation viewed from the camera parallel to the floor. We can see that the marker separation decreases over time. The small increase in the middle is due to the card's rotation. The right plot is the marker separation viewed from the camera that is facing the wall. We can see that the marker separation increases over time. We can observe from these two that the card rotates around the axis parallel to the axis of the motion. We can see that the card rotates around that axis as it flies along. Now I'll define a few parameters related to the card's motion. First, there are some axes. The U-axis, V-axis, and W-axis are based on the card's direction of motion, with the V-axis being the direction of motion. Then the X-axis is defined as the meeting line between the plane that has the V-axis and the W-axis and the plane that encompasses the card itself. Then the Y-axis and Z-axis are based off the X-axis. Now I'll define some angles. Theta Z is defined as the angle difference between X-axis and the V-axis. And then theta X is defined as the angle between the U-axis and the Y-axis. Now are the forces acting on the card. First, the aerodynamic forces, lift force and drag force act on the center of pressure, with the lift force being perpendicular to the direction of motion and the drag force being in the opposite direction to the direction of motion. The gravity acts on the center of mass. It is known that the center of pressure is in a different point from the center of mass. Now let's look at some card motions that are related to the card's trajectory. First is the tilting motion. We can see that as the card flies, the card rotates around the direct axis parallel to the direction of motion in the air. This is due to the torque acting on the card due to aforementioned difference between the center of pressure and center of mass. That difference makes the aerodynamic forces exert a torque on the card, which make the card rotate, which causes these movements. The excess torque caused on the card can be divided into a torque that is on the same plane as the angular moment of the card due to its spin, and then another torque that is perpendicular to that same plane. Using the torque that is on the same plane as the angular momentum, and if we define that torque as L dot and LT as the original angular moment due to the card's spin, L dot changes LT to LT plus DT, and that makes the card rotate around the X-axis. This is the tilting motion. And next is the gyroscopic motion. We can see that the card follows a curved trajectory as it flies. This is due to the rotating torque. The rotating torque is perpendicular to the plane that the angular moment due to the card's spin is on. This rotating torque, if we say that as L dot in this case, that L dot changes the LT or the original angular moment into LT plus DT. This makes the card rotate around its y-axis. And as the card has some velocity as it is moving forward, the combined motion between the card rotating around the y-axis and the forward motion due to its velocity makes the card follow a curved trajectory. Now let's look at some relevant parameters first related to trajectory. The relevant parameters related to trajectory are the initial orientation and the initial velocity squared over omega. And then there are the relevant parameters related to distance. There is initial translational velocity, the initial angular velocity, and the initial soaring orientation. Stall conditions weren't considered here because to predict when stall conditions will happen, there needs to be ideal conditions, but in real life conditions, we can't predict when stall conditions will happen. So we didn't consider stall conditions. Next are the experiments that prove the relationship between the distance and the relevant parameters and observing the trajectory. Using a motion analysis and a throwing machine, we analyze the trajectory and distance of the car's flight. First is the trajectory. Using the motion analysis data, we viewed the trajectory of the car's motion from multiple perspectives like this. By analyzing the trajectory of the car, we divided the trajectory of the car into two sections, the curving section and the straight section. The curving section is characterized by a large theta x value and a significant effect of the gyroscopic effect. The straight section is characterized by a small theta x value and a small gyroscopic effect. The straight section and curving section can be differentiated perfectly, but we differentiated them only for characterization purposes. And using these different sections, we can see the relationship between the initial orientation and the trajectory of the car's motion. These two are trajectories of the car's motion with different initial orientations, with the left one having the initial theta x value of 33.8 degrees, and the right one having an initial theta x value of 0 degrees. We can see that the length of the straight section is different for these two trajectories. From this, we can observe that with the trajectory with a larger initial theta x value, the time the car flies in the air with a small theta x value is longer, which means that if the car is thrown with a larger theta x value, the car has a longer straight section compared to the curving section. Next is the relationship between the v0 squared over the omega and the trajectory. Sorry for the error there. It's a relationship between the v0 squared over omega and the trajectory. The larger the value of v0 squared over omega is, the more curved trajectory is, because the tilting motion will be more pronounced. These are the 5 trajectories with different v0 squared over omega values. Difference, I divide these two because these two have different initial conditions. So giving a more explanation on that, since the v squared over omega is related to tilting and gyroscopic angular velocity, a higher v squared over omega value means that the trajectory's curvature is higher. Next, let's look at the relationship between the flight distance and the relevant parameters. First is the relationship between the flight distance and initial translational velocity. You can see that as initial translational velocity increases, the flight distance increases. There is no perfect relationship observed between them, but we can see a tendency between these two. These two compare the relationship to flight distance and the initial translational velocity with the other parameter difference such as angular velocity and theta z value. From this, we can observe that the parameter initial translational velocity is independent to all the other parameters. Next is the relationship between the flight distance and initial angular velocity. We can observe similar patterns between these two parameters too. And we also did observe an exact relationship, or only a tendency, that the flight distance increases as the initial angular velocity increases. We also observed that the parameter initial angular velocities is also independent to all the other parameters in a similar way as before. Similarly, we observed that as the initial theta z value increases, the flight distance increases too, and the initial theta z value is also independent to the other parameters. Same was observed for the initial theta x value. Now I'll give a more elaborate explanation on these results. First is about the initial angular velocity. Since the tilting speed is since the tilting speed is proportional to the ratio between the applied torque and the original angular moment due to the car's spin, and the original angular moment is proportional to the initial angular velocity. If the initial angular velocity is larger, the tilt motion is slower. Then the distance the car flies with small theta x value is longer. Sorry here. This means that the car flies straight for longer. And next, I'll make a conclusion about the trajectory. The trajectory can be divided into two sections, the straight section and the curving section. The ratio between the length of the straight section and curving section depends on the initial orientation, or more precisely, the initial theta x value. And next is a conclusion for a longer flight distance. For a longer flight distance, the car needs a high initial translational velocity, a high initial angular velocity, a large initial theta z value, and a large initial theta x value. These are the references, and thank you for listening.
Okay, now opponents, feel free to ask questions to the reporter.
First of all, thank you for your presentation.
Yes.
And the problem statement mentions a standard playing card. And how do you define the standard playing card?
A standard playing card, we use the bicycle cards for
Is
this.
there any special properties of this playing card they use that you might have missed, like a standard playing card?
Well, I'd say for a standard playing card, the card is made of plastic or paper and is about rectangular
Okay,
inside.
so rectangular plastic paper, did it bend?
Bending wasn't actually observed that much.
So you did not have any bending material. The card can bend theoretically, right?
It can bend theoretically, but we didn't observe it.
I'll move on. Let's talk about the discussion. Do you have any quantitative theory that you can actually use to compare the experiments?
Quantitative theories couldn't be used because there are so many parameters surrounding the card.
So you don't have one.
So we don't have any
Okay,
quantitative
thank
data.
Did you consider any other aerodynamic effects other than the drag force and lift force?
Such as
The Magnus effect?
Magnus effect won't be affected because the card is so thin.
No. If you see the surface of the card, the two parts of the card have different velocities. And it could cause the card to tilt.
The Magnus effect affects on the side of a rotating object.
Anyways, okay, so no any other effects than the lift force and drag force.
Yes, other effects are negligible.
How did you calculate the drag force? Did you calculate the drag force?
We considered all of the drag forces that could act on the card, such as surface friction drag or aerodynamic
So how
drag.
did you calculate it? Did
Well,
you use
surface-
it proportional to the velocity or the square of the velocity?
Well, aerodynamic drag is proportional to the square of velocity, and surface friction drag was
Sometimes
calculated
it's
to be
proportional
negligible.
to just the velocity, you know that. In slow speed conditions, right?
What? Can
In
you
slow
repeat?
speed conditions, it might be proportional to the velocity, not the square. How did you determine where to use what?
Well, since the card is sort of like a projectile flying through the air, I did consider that the drag could
Thank
be
you.
proportional.
Okay. Opponents, please take a moment to take the stage.
First of all, I'd like to thank the reporter for his excellent presentation again. And I'll now start my opposition on number 17 playing card. My name is Untitled Chapter from Team Hyundai Senior. Okay, first of all, problem statement again. So the problem statement's important part is that there must be a standard playing card that has conditions to travel a long distance while the spin is incorporated. Also, they must investigate different parameters that affect the distance and the trajectory. So now let's move on to the summary of the report. So they first have some observations and premises. They first didn't define a standard playing card in this case, but they did define other variables such as parameters and the trajectory by doing a preliminary experiment. And then they had a theory on the lift force, drag force, but they did not have any on the flexibility. They have some specific questions on the angular velocity, translational velocity. They did a good job on this part. And they had the experiment and tried to compare it with the trajectory, but we'll look at this part later on. So some strengths and weaknesses. So the reporter had some great strength, such as having a very detailed preliminary experiment on the trajectory, had a well-set qualitative theory that could explain the phenomenon qualitatively, and they had an intuitive explanation of the trajectory, and they had very clear definitions. However, they also had some weaknesses. One of the main ones being the lack of other aerodynamic forces, the lack of quantitative theory that could be actually compared with the experiments. They had no consideration of the bending of the card, which I'll show you in the discussion that could be very fatal. There was no definition of standard card, where the problem statement mentioned standard card. Lack of explanation of the oscillating results, while here all of his results oscillated. They had missing error bars, so the reliability was not that great. And there was no analysis of the experiment except for the tendency, so they didn't know if it's linear or if it's quadratic or anything like that. And as I said, there was no direct comparison with the theory, and although they defined many variables and tried to experiment with many variables, they actually never used it to compare with the theory that well, and their theory was only qualitative. So, quickly, I would like to move on to the discussion with the opponent.
Okay.
Okay.
Would you like to ask me something first?
Yes, of course. Thank you for the presentation again. And first of all, I would like to ask you about this other aerodynamic forces that might be acting.
Can you elaborate? Like, can you give an example on what could affect card motion?
So shouldn't there be a pressure difference on each side of the card, on top or the side? Because there's different velocity, they're traveling at different velocities.
Okay, the thickness of the card is 300 micrometers. Would that be a sufficient height for any pressure to act on it?
But did you calculate the forces that could act on it? Exact force that could act on it, not just measure the side length?
Well, the surface area of the side of the card is negligible compared to the flat area.
So you ignored all other aerodynamic effects that could affect the card. How about turbulence?
Turbulence? Since the card is flying through the air and, well...
Yes, when it's flying flat, you might be able to ignore turbulence, but in your theory, you mentioned the curving part. And when you're entering the curving part and the card flies in a random trajectory, wouldn't it matter?
Well, we observed that the card doesn't tumble through the air and actually flies in a certain trajectory, which means that if there was turbulence, the card would be tumbling. So if there was no tumbling visible, we can say that there's no turbulence.
So the card never tumbled, even in the curving part? No matter the initial velocity.
Also, the Reynolds number is used to define the amount of turbulence.
What was the Reynolds number?
Reynolds number is a number that shows how turbulent the airflow is,
So what
right?
was the Reynolds number in the experiment?
Well, we calculated the Reynolds number and we got about 10,000, which means that it's pretty linear.
Anything over 2,000 can be turbulent.
What?
Anything over 2,000 could be turbulent. So your flow could be turbulent.
Well, if turbulence was actually relevant, then the movement of the car would be very erratic, which we didn't observe.
So you just noticed that your car movement is not as erratic and completely no turbulence. Let's move on to the next theory. So you agreed that you had no quantitative theory, right?
Yes.
So you can't although you examine different parameters of the card, if I give you initial state, you can't really predict the trajectory, can you?
Well, I said that I ignore a few other forces, but there are actually quite a lot of the...
So can you predict the trajectory if I give you the initial conditions?
I only did the qualitative theory because it's,
You can't.
yes, I can.
Thank you for answering. Next, the bending of the card. So you ignored the bending of the card because you said that it was not significant. But if you see on the card,
Yes,
when the card is bent,
yes,
like so,
Yes.
always, of course, it's going to be less bent than this, but just for the diagram.
okay.
this part is going to be receiving more drag than this part. Do you agree? And this
If
could,
it is bent,
this could
yes.
cause the card to tilt. Do you agree?
If it is bent, then yes. I agree.
So even if the card is slightly bent, it could cause the card to start tilting. And it could be an effect of some major tilts because, yes, as it starts tilting, it starts using the drag force even more. So,
Yes.
the flexibility and the bending of the card could greatly affect this phenomenon and you didn't measure it. So
Yes, I agree. I measured the actual bending of the card. So I set the 3.8 center of mass and B, right? So by measuring the angle between the two lines drawn between the center of mass and point A and the center of mass and point B, we could measure the angle between these two lines, and by measuring the angle, we could tell how much the card is bent. And the angle between these two lines are about 0.9 degrees, 0.8 degrees, 0.7 degrees, and 1.3 degrees. This means that bending is almost negligible.
you're saying the bending is completely negligible.
Because bending is almost not observed
But
in the card's motion.
even if the bending is very small and there's a very small amount of angle, when the bending is present, it could be the condition for starting the rotation of the card.
Well,
Well, how do you explain the rotation of the card without rotation of the card then? It's the initial rotation of the card. How
Well-
it starts spinning upwards.
Well, if the card is thrown like this, then it should still spin in the same axis, right?
Okay, if you throw it in parallel, does
Yes.
it not go up or down?
Well, it should first start going down. Then,
Okay, so it
because then the card still gets some angle of attack compared to its relative motion, then it gets tilting moment.
So you never observe the card going like this when you throw it in parallel?
If that happens, then that means that there is a small angle of attack when you throw
Or
it.
so you're claiming that without an initial angle of attack, the card cannot tilt upwards.
Well, first of all, when you're throwing the card with your hand, you can't actually assume that there is zero angle of
Did you
attack.
throw the card with the hand?
No, I did not.
Well, okay, well then. So you're claiming that when you throw the card in parallel, so with no initial angle, then you can't. Then it does not receive a tilting force towards the up.
No, I said again, if the card starts going down, then the angle of attack actually forms, then the card starts tilting.
I'm going to the next question. Could you have my PPT up again? Okay. Also, okay, conditions for flight. So you
Yes.
mentioned, okay, what are the conditions for flight?
Well, there is the initial orientation and the initial angular velocity
Yeah.
and initial angle.
So what is the best initial angle that you found for the
What
for-
angle? Initial Z,
Yes,
X.
the flying angle, like this angle.
You mean the angle of attack?
Yeah.
5 to 15 degrees, because anything beyond that would make the cause the card to stall.
5 degrees.
5 to 15.
5 to 15. Was it
Some
5 to
of it.
15 for every cases? Did you experiment with any other cards or any other? So it was between 5 to 15 for every velocity.
Well, yes, we did the experiment for initial Z to Z value, which is the same as angle of attack.
Alright, so regardless of the initial angular velocity or initial linear velocity, the best angle of attack was 5 to 15 degrees.
Well, I showed in the experiment that larger theta X theta Z value, the lot farther it will fly. So
yeah. So
15
it was 5 to 15 for every
Well,
experiment.
yes,
And you don't have any theory on why that's so. No quantitative theory.
It's just empirical.
It's just assumption, not a
No,
quantitative
it's an
theory.
experimental result.
Yeah, for a theory, not the results.
For theory, since the angle of attack is relevant to the flight of the card, then I just assume that the theta Z will be a parameter, and then I start the experiment.
Let's move on. Also, for the angular velocity, we're claiming that if the angular velocity is faster and faster, it just travels farther. And there's no like limit point.
Well, yes, no limit point
No
for
limit point and more angular velocity means farther in card.
yes.
Okay.
Well, above a certain point, the velocity of the card and the drag acting on the card will dictate the
Also, you say
total
there is a
direction.
limit.
Well, it would show a graph something like this because of I'm not saying that there is a limit. I'm saying that if it gets faster and faster, the effect will diminish.
I think I get the point. Experiment setup. How did you fly your part? Your experiment setup was very. I couldn't see it off clearly, and the video was not there. I think.
Well,
Wait. Did you have a video for your device? Shooting a card?
I have a photo for it.
No, the video, so that we can see how the card flies. Do you have them?
Well, what video? The video
The
of
video of your
advertising.
device shooting the card, not your hand and not the photo of the device.
Won't the photo be enough? Because there is
No,
the
yeah.
smartphone.
If you have to see how the card flies on the device, to see if it's stable, see if it's correct and everything. But if you don't have one, let's move on. So I
Okay, next point.
So I saw your results. I saw your results did not include error bars. Why is that so?
Each point is an individual experiment result, so there are no error bars.
Well, you have to conduct the individual experiment multiple times to be able to see the reliability. That's why you need error bars. But you do not have any. Error
That's
bars.
why I plotted all the points out, because by showing the entire spread of the experiment data, we could still see a tendency.
No, but in case of experiments such as initial velocity to the distance it travels, you have to measure it multiple times to have error bars. You don't have any error bars on that graph as well.
Well, I just used a different plotting method. Instead of taking the average of the 3 data points and plotting them out, I just plotted out all the 3 data points and saw the
So you
entire dispersion.
So you experimented just 3 times and put 3 data points there?
No, for three experiments are the same condition and more experiments are different conditions.
Okay. I think I saw a regression line on your graph. How do you draw that?
Regression line?
The line of estimate.
Can you elaborate?
Did I miss it? I think I saw a line of estimate in your graph, but you didn't have a quantitative theory, so how did you draw that?
If there was any line in our graph whatsoever, it may have been an error that's surpassed, but we have no lines of regression that we meant to put in the graph.
Okay. I think you used the center of mass, the center of the card.
Yes, center of mass.
But as far as my knowledge, in aerodynamic motion, the center of mass and the center of pressure might differ.
Yes, I said that it differs.
Okay, so how did you conduct it with this in mind, your theory?
Well, my theory, the point of my theory is that the difference in the center of pressure and center of mass causes the torque on the card.
Okay. Now I want to mention the effect of drag and lift in your case.
Yes.
So, although you don't have a quantitative model,
Yes.
you said that you just modeled the drag and lift force as the square of the velocity, right?
Yes.
But are you aware that in case of very viscous or slow effects, they might
Yes.
be response to
For very slow card motion.
what about downward falling motion?
Downward fall motion?
Yes, this is hard.
I think that the effect of lift will be much larger than the effect of drag.
So you ignored it.
Also, I'm aware that what you're saying, that drag is proportional to velocity, is only when the Reynolds number is about 10 or very small.
Okay.
And our Reynolds number was actually pretty large.
So use the Reynolds number for your theory.
Yes.
Okay, I get the point. So here's one last thing that I want to ask you. With your theory, could you predict how far the card goes, or the trajectory of the card, or just anything at all?
The trajectory can predict it, and we can vaguely predict the distance.
Predict.
Yes.
Isn't the trajectory also vaguely predicted? Do you have a model for that?
Well, there is the qualitative model, and I provided a couple of parameters that dictate the trajectory of the card. So I think I can predict the trajectory of the card with these parameters provided.
Also with your device, how did you give the spin to your card?
Well, I could show you that with the photo. The smart card extends an arm that hits the side of the card, thus applying rotation and linear motion at the same time.
So you're hitting the side of the card.
Yes.
Couldn't that give initial z, y, x value? And if you're doing so, how can you predict that?
We're hitting.
How can you predict it? How can you set the exact initial conditions?
Well, first of all, the hitting rod is perfectly parallel to the card. We said.
Well, I think the time's up. Okay, thank you for your answer.
Okay. Owner, please.
Okay, so although the reporter gave us a very good qualitative analysis of the experiment, he did not have any quantitative analysis. That is, he did not have a theory that could actually predict the experiment. And even for the qualitative model, he only considered the simple drag force and lift force, which he didn't even define properly because he didn't take account of any other aerodynamic forces. And also, as for his experiment, while he showed this experimental device, he did not show any video, which basically means that we cannot see the validity of the experiment. Well, but he still had a lot of graphs and value of a lot of graphs and results. However, if you see his results, there is absolutely no error bars. And he only predicted the tendency of the card, which is quite obvious. So he only predicted that if the velocity is high, the card goes farther, which is obvious without the experiment. He did not have any relationship. Was it like linear? Was it quadratic? He did not have anything like that. So all in all, although he had a good qualitative explanation, it had no quantitative, and the experiment did not match. Thank you.
Okay. Reviewer, now feel free to ask questions to both the opponent and the reporter.
First, I'd like to start with asking the reporter about, can you explain briefly about your observation on the card's movement without a spin?
Well, if the card doesn't have a spin, the card will just tumble through the air, mostly
Can you
back.
explain your observation results?
Well, I can show you right here, right now with this card.
We'll move on to the next question. Since the problem statement clearly states that the spinning card goes a long distance, what are your numerical criteria for a long distance?
Well, I said that I don't have a quantitative theory for this. I only provided the tendencies and qualitative results.
From my understanding, you don't have a theoretical trajectory, right?
Well, yes.
Then how can you verify your theory when you can't compare your theory and experiment?
Well, I tried to qualitatively explain the trajectory instead of comparing the theory and experiment.
For the opponent, first I'd like to ask you the effect of bending in this phenomenon.
The effect of bending, well, as I explained in the discussion, the effect of bending can cause the initial start of tilt.
And you mentioned the Magnus effect as the possible aerodynamic forces on this phenomenon. Do you think this is significant in this phenomenon, and can you elaborate?
Well, honestly, I don't think it's that significant, but if you wanted to ignore this model, he would at least have to see the forces that act model before he ignores it.
For this, the same question as the reporter, how can do you think this theory and experiment are accurate?
Well, he did not have a theory, so I don't know if it's accurate, and the experiment was not as well. He did not have any error bars.
For the reporter, can you elaborate more on your throwing machine?
Throwing machine? Well, I use a spring that has a constant. I use a spring with a constant angle compression, consistent amount compressed, and since it's consistently compressed, then apply a consistent force on the card, and the spring hits the card in the same consistent position, which means that a consistent force is applied on the card.
And for the graphs for the observation results, I realized that the x-axis are explained as meters.
Sorry, that could be an error. Well, yeah, well.
Not this one, for the actual experiment.
Which experiment are you talking about?
So, can you go?
Okay. Reviewer, please take a moment to prepare to take the floor. Okay, reviewer, you have the floor.
This is Isu Hong from Team Format from Hana Academy School. I'll be the reviewer for the number 17 playing card. This is a problem statement that you have seen before. And for the reporter review, he first did a force analysis related to the lift force, drag force, and gravity. And he also explained the notation of the tilting and the gyroscope. He divided the curving section and the straight section for the trajectory of the car movement, and he also explained the ratio between the length of the straight section and the curving section. For his experimental approach, for the pre-experiment, he used two camera angles looking at the flight trajectory and the tilting motion. The relevant parameters he used were the initial condition, the translational velocity, and the angular velocity. He analyzed the result data using the graphs. The strength and weaknesses for this reporter was that he first simplified this complicated motion of the car. He divided the trajectory into two sections, which was a clever idea, and he had a good experimental setup using a machine. However, the weak points of this reporter was that he did not mention any criteria for the probabilistic statement, which was long distance, or any definition of the spin was not mentioned. And there was no match between the theory and experiment, which means that he cannot verify his theory. And lastly, no bending motion of the car was mentioned. For the opponent review, he pointed out that the reporter had a good qualitative analysis of this problem. However, he mentioned that he lacked any mentions of aerodynamic forces, or he missed error bars, which would analyze this, verifying his theory. For the discussion points, he pointed out any effects of aerodynamic forces, bending of the card, conditions for far flight, experimental setup, or the existence of error bars. The strong points for this opponent was that he pointed out the ignorance of the aerodynamic forces of the reporter, and he also required for the experimental video, and the explanation of the device. However, for weak points, they did not concentrate on the graphs that were provided for the observation, and did not criticize for the problem statement, which was, as mentioned before, the definition of long distance or spin. The discussion points, the first discussion point was the aerodynamic forces. The opponent mentioned the Magnus effect, but in my commentary, we agree with the reporter, since the small leading edge makes the Magnus effect very small. Next, the bending effect. The opponent pointed out any bending effect will happen in this phenomenon, and the reporter said that it is negligible. But for this case, we agree with the opponent, because the bending of the card should be carefully examined in this complex movement. This is it for the review.
Okay, reporting team, you have 2 minutes for final remarks.
Thank you, everybody. I would first like to point out the fact that the trajectory was investigated by obtaining experimental results and trying to explain that trajectory with the theories provided. This is not a matter of matching the theory and experiment. Instead, it is a matter of explaining the experiment with the theory. Also, the distance was only investigated with the experiment due to the complex nature of the card's motion. Using these methods, I qualitatively explained the conditions for the car to fly a long distance, which I provided in conclusion, and also the effects of spin on the car. The forces not covered, effects not covered, such as the Magnus effect or the bending effect, or any other effects such as skin friction effect, or either negligible, which was observed experimentally, or just calculated to be negligible due to the geometric conditions of the car. I would like to wrap up that the question stated to investigate the trajectory and the flight distance of the card, and due to the complex nature of the card's motion, I could not make a quantitative model for the motion, but I succeeded in making a qualitative model for the card's motion and explain it well with the experiment and theory. Thank you.
Okay, I would like to thank all three teams. Now the jurors will ask a couple of questions.
For reporters,
Yes.
you define the center of mass for the rotating card, but it's not. It's non-inertial frame. And but you measure the phenomenon at the rest frame, then kind of effective torque can be included. But my question is, how can you claim the intrinsic rotational effect? Because you defined the center of mass, but it's accelerating in very complicated motions.
Well, I define the center of mass as the geometric center of the card due to the card being symmetrical in all directions. Well, in the two directions.
So my question is, parallel motion, accelerating the parallel motion can affect the rotational motion as an effective torque. You cannot separate such the center of mass motions from the parallel motion.
Even if there was an effect of the card's inertia, I would still think that the effect due to the aerodynamic forces would be greater than the effect of inertia.
Okay, for opponent, you mentioned about the bending effect. If bending effect is significant, regarding the shape of card is rectangular, it's not square. Do you
Yes.
think the rectangular shape has some advantage?
Rectangular shape.
Yeah, to lifting effect or long distance.
Yes. So with the bending, so sort of like a helicopter wing, when the shape is rectangular and not simply equal on sides, it could cause, when it's bent towards the top like this, it could cause some extra lift force, which could also affect the phenomenon.
Okay, to the reporter,
Yes.
what is the origin of the lifting force in your force diagram?
The lifting force? The lifting force is the aerodynamic lift force due to the angle of attack of the card.
So how does it affect it by the spin?
The spinning doesn't directly affect the lift force. It actually dictates the tilting speed, because if the tilt goes too far, then the card will tilt over to the side. Then the lift force will be acting sideways, not upwards, which means the card will draw. That's why I set the spinning speed as an important factor in the card's flight distance.
Okay, then what makes the card fly longer when it's spinning?
Because the card maintains a flat situation for longer, the card will get lift will be exerted on the card for longer, which means that the card can fly for longer.
Opponent, you've asked for a video of the flight of their card. If they did have the video, what information would you want to gather from their video of their experiment?
Well, first of all, I want to see how they spin the card, because as they mentioned, they might have spin the card by hitting it or something, and hitting could affect the motion. I want to see how stable the card flies.
How stable? But
Yes.
then you looked at their data. Do you think they presented all the data points from their experiment?
Well, their X graph started from not 0 but like 3, but I don't know if there's error in tracking or if they missed some data.
Revere, you've commented that they use some clever about separating the various components. Do you think it's kind of disservice for them to compare and that it meets their theory by just showing the trajectory?
I'm sorry, can you repeat your question?
I think you've commented that that they did well in trying to separate very small chunks of the theory, but they kind of argue that their theory works by just looking at the trajectory graphs or the position graphs. Right? Do you think that's enough?
Well, for the dividing steps for its phenomenon, we thought the dividing step itself was clever, but no numerical or quantitative definition of the theory was provided. So I think it lacks accuracy.
Then I have a question for. I'm sure you use the high video camera, and for duration of the flight, I'm sure you have like 1,000 frames to analyze, but you probably showed about 1/10 of it. And why did you not show how the angular velocity changes with time or as position?
Well,
I would think that would be a better way for you to separate your straight and your gyroscopic motion, but it's very fishy that you failed to show how the angular velocity changes, especially when you're arguing about torque.
well, I thought that the angular velocity wouldn't change much because skin friction drag on the card is very negligible.
Then you've stated this as a drag effect that makes the gyroscopic flight. No.
So,
You said that there's a torque on the card, not by gravity, but by this.
can I be clarified which axis of angular
No, the
motion?
only clarification that I would ask for is why did you not plot the angular velocity?
Well, the
And
view
wh-
angle of the
And how long was the flight?
due to the view angle of the camera being small, I couldn't actually measure the entire flight. But using the motion analysis, I measured the
So
flight
how
time.
many data points? About 1/10 of the data points did you present?
For the motion analysis, I presented all the data points, and the flight time was about
Really?
3 to 4 seconds.
I'm sure you have a millisecond camera, but you only showed about 100 data points.
Well, the high-speed camera was only used in preliminary experiment, and the rest was done with motion analysis system.
Okay.
Very simple question for the reporter.
Yes.
Have you tried to compare the say flying distance with and without spin?
Without spin, the car will just tumble to the ground, so it will be meaningless to actually measure the distance.
When you measure?
Well, since it's a tumbling motion, it will be very random, dictated by turbulence. So I didn't think that seeing a tendency in that will be relevant.
Okay. So I have a question for the reporter. So you reviewer, sorry. You mentioned about the definition of the long distance. So if you are the reporter, then how could you define the long distance?
I would define the long distance compared to the distance flight by the car without a spin.
Okay, thank you.
Are there any other questions?
So for the reporting team,
Yes.
so if you have a very thick card which is very heavy,
Yes.
and you have the same size thin card,
Yes.
and you just throw without any spin, which will go farther.
Well, if it's a very thick card, it will sort of be like a brick flying through the air, whereas a thin card would get lift and also be affected by the torque acting on the card due to the difference in the center of pressure and center of mass.
It will fly longer.
If with a thick card, it's like a brick, so it will just be like throwing a brick. With the card, it will fly much longer because it gets lift. If you throw it at a higher angle, then it will work. But I threw the card close to the ground, and because I threw at pretty much 0 degrees angle in this perspective, so the card didn't fly long until it hit the ground. Well, it can be thrown farther, but it wasn't done in this case. Because to throw the card actually very long, then you have to throw it by hand, which makes the experiment very unreliable.
All right, if there's no more questions, the jurors will add up the scores. I'll try to read as slowly as possible. First, the scores for the reporter team. Five, 6, 7, 8, 6, 6, 6, 7, 9, 6, 7, 7, 5, 5, 8, 6, 4, 6, 5, 5. All right, now the scores for the opponent team. Seven, 7, 6, 8, 9, 7, 8, 8, 7, 9, 8, 10, 9, 8, 8, 8, 7, 6, 7, 5, 6. Scores for the reviewer. 6, 6, 7, 7, 8, 7, 7, 8, 6, 8, 7, 9, 8, 7, 7, 8, 6, 7, 6, 7, and a 7. Okay, we'll take a short 5-minute break and come back for the second round. Alright, if we could get everybody seated and ready, we'll start with the second fight of the final. Alright, the reporting team, please take the floor whenever you're ready.
Alright, hello everyone, my name is Tae-Hong Lee from KMLA's Hail Seniors, and today I'm going to be presenting number 10, conducting lines. Now let's have a look at the phenomenon. A line drawn with a pencil. I'll continue. Sorry. Right, so I'll start with my observations of the phenomenon. A line drawn on paper by pencil can be electrically conducting, as shown by the illuminated LED over there. My job is to investigate the characteristics of such a conducting line. Now first, I had a look at what the enhanced surface would be using a scanning electron microscope. Now, I drew the lines, 3 lines on paper, as shown, and I had a closer look, magnified up to 501,000 times using a SEM. Now, you can see that the surface of the paper is very random and very complex. So, modeling quantitatively at a microscopic level is too random and complex. So our objective to this problem is to connect the microscopic and the macroscopic level with my mathematical model. Now, I'm going to achieve this with my theoretical model. Let's see, we have a graphite line drawn with pencil over there. And I'm gonna model the graphite line as spherical particles of graphite. Note that these graphite particles are actually graphite atoms. There are a whole bunch of graphite layers. Now, I want to calculate the resistance for each and every spherical unit. Then I'm going to calculate the resistance for the whole rod. Then I'm going to calculate the resistance for the whole graphite line. So my first step, right? I'm going to model the line with spherical particles, the graphite pencil on paper, and I'm going to predict the resistance with my model. Now, why does graphite conduct electricity? Because graphite has a valency of 4, but it has 3 sigma bonds but 1 pi bond, meaning that this pi bond over here can move around freely around the graphite structure, meaning that the graphite line can conduct electricity. Now, since I'm going to predict the resistance with the model, with the spherical model, I'm going to calculate the resistance of this unit length, unit sphere right here, with the radius of the sphere of large r and the contact radius of small r. So if the current is flowing this way, if you integrate and calculate the resistance, we get this equation right over here. Now this equation is the resistance of one spherical unit. Now since we know the resistance for one, we can calculate the resistance for the whole graphite rod. And I'm going to call this graphite rod a caterpillar rod because it looks like a caterpillar. Now, I'm going to bring this rod to the macroscopic level because these spherical unit resistances are connected in series. So you have to multiply the amount of unit resistances in the whole rod to get this equation over here. Now, since the graphite line is not consisted of just one caterpillar rod, but several caterpillar rods, we have to see how many caterpillar rods there are in a unit cross-sectional area. But since we're going to measure the dimensions of the graphite line, we have to compare how much of the difference there is between our spherical rods and our rectangular prism. So I'm going to call this cross-sectional area ratio beta. Now the meaning of beta is the resistance of the caterpillar rods according to the resistance of the rectangular prisms that we're going to measure, which is going to see if our model for the conductivity of graphite line is valid or plausible. So we calculate that, it's connected in parallel, so you add onto the area to get this final resistance over here. Now, this looks very complicated, but we just make it a little bit more complicated using the temperature term. But in fact, it's not really that complicated, it's just the length, the resistivity, and the area. And we're going to bring the microscopic level to the macroscopic level, predicting the net resistance with large r, small r, and beta. These 3 variables right here. So for my preliminary experiment, I used a pure graphite pencil. Note that it's pure, but it is not actually 100% pure graphite because manufacturers in the real world cannot make pencils that are made of just pure graphite or else they'll break very easily. So graphite pencils are actually made with a mixture of clay. I try to reduce the clay as much as possible because we were trying to investigate the graphite line. I use a pure graphite pencil of 6B to make it as minimal as possible, the composition of clay. For my experimental model, I use an electronic scale to measure the force amount of force I'm using along my experiment. And now I have to try to minimize my effect of paper with beta. Because remember when I showed you the photo of the SEM, the very random and complex structure of the paper? We cannot exactly model individually the surface of the paper because it's very bumped over here. We're gonna solve this with beta. If we solve for beta, we can know the ratio between these two areas, and if we calculate the area for the gray part, we have our conductivity of our pure graphite lines. So I took this as a control variable. To minimize the effect of paper, I had to maximize the area of the gray. So every time I conducted an experiment, I drew 500 lines with an average pressure of average force of 13.72 newtons, and then I analyzed it. I processed this through my scanner to get the HTML color code for this. And I analyzed the RGB values and made sure that these were below 50. If it were pure black in a computer screen, it would have been 000. I kept it below 50 for every single time. Now, for my first preliminary experiment, I calculated the line height by if you draw the line with a pencil, we can calculate the amount of volume that we use the pencil, and this volume decrease in the pencil will be the exact same amount of the volume that the graphite line is consisted of. Since we can measure all of these values except for the height of the line, we can calculate for the height of the line to get this. If you can ask me during our discussion. We're going to keep this line height as a control variable. Now for my second experiment, I checked if it followed Ohm's law to see if I can measure resistance with the voltage and current. However, it did not follow Ohm's law, meaning that to measure the resistance for our experiment, we cannot use the voltmeter and ammeter. Instead, we have to use a multimeter to measure the resistance right away. Now for my third preliminary experiment, I calculated the resistivity of this by using just a simple formula for that, and it turned out to be 0.0040 ohm meters. Now for my actual experiment, my first specific question was the compaction of the line. Because if we apply a force onto the surface of the paper, then the distance between those two graphite layers is going to be changed. And this change in the distance between them can cause a difference in conductivity. So I varied the mass and the force using water, and we just know from here that we can calculate the force applied as a function of the water height. So that's what I did, and if we notice that there is not much of a difference when we apply the force in our level of 13.72 newtons. So throughout our experiment, I'm going to ignore compaction as it is negligible. For my second specific question, I checked it had a linear relationship with the length, and I varied the line. I used one single line to ensure I reduced as much errors as possible, and I got this. Now, the blue dots here are the experimental dots, and the orange line is the theoretical line we use for this equation right over here. And now, since our goal was to get values for large r, small r, and beta, we got these as 10 to the negative 6, negative 7, and 0.97. My third specific question was the width. I used the same experimental equation for this, and I got a similar result. I kept the length a control variable and the temperatures of this time, of course. My fourth specific question was the radius of curvature. Why I did this? Because the question asked that we draw the line on paper. However, we know that the paper is very flexible and can bend. And what happens if we draw the line on folded paper? Would there be much of a difference? I tried to investigate this phenomenon because if you curve the paper as shown, there's going to be a notable distance change. And what this means in our theoretical model is that these caterpillar rods that was initially flat is going to curve and now break out in the top parts of the caterpillar rods. Meaning that the value of beta is going to decrease. So we have to find the function of beta as a function of the radius of curvature, because beta has decreased. So I used cylinders to wrap my paper around. I used a 30 centimeter graphite line for my control variable. Of course, I drew it 500 times and scanned it through it and made sure that the RGB values were lower than 50. Right, I wrapped it around and then I used a multimeter to calculate the resistance, and I got this as shown. Now, we can see that beta is changing because beta is a function of radius of curvature. To see this, I made another function of the beta function against the radius of curvature, and you see that as the radius of curvature decreases, meaning when the paper is folded, more and more layers of the caterpillar rod break, causing a lower beta value. While on the other hand, if it goes to a completely flat surface, it reaches a maximum point. This can be modeled experimentally with a logarithmic function. Now, my fifth specific question was the temperature. Because if we apply heat or take away heat from our graphite line, we can see a notable distance change as well. We can predict the notable distance change. Therefore, I used temperature in our theoretical model and I compared it with our experiment. I used an infrared for the thermometer. I put the graphite line in the freezer. I put it on room temperature. I put warm water. I put it in boiling water to measure the temperatures and the resistances. I got these data as follows. And I noticed that the large R, small r, and beta values were constant. However, the value of alpha was calculated here, and alpha was 0.062. Now, for my conclusion, I tried to bring the microscopic level, the almost seemingly impossible structure of paper, to the macroscopic level in real life with my theoretical model. And my value for the predicted resistance consisted of the values of large r, small r, and beta. And we calculated our large r, small r, and alpha and beta. And we also noticed that the radius of curvature affects beta as a function. Thank you.
Okay, your opponent, please feel free to ask questions or report.
First of all, thank you for your presentation, and I'd like to ask you a few clarification questions.
Of course.
First of all, so you have considered the force the pencil acts on the paper, correct? Then did you consider the pressure and the surface area the pencil makes with the paper?
Yes, that was my specific question number one.
Okay, well, I'll be discussing that later on too. Also, we have matched your experiment to your theory. However, we couldn't see R-square values in all of your data regression points. So did you calculate the R-square value for your linear regressions too?
Those aren't regression points, those are my experimental lines.
Oh yes, did you actually linearly regress and then investigate the R-square values of those data points?
In Excel, you can't calculate you can only get the regression line from the data points, not calculate the result.
I think you're misunderstanding my question, so I'll be asking that later on too.
Alright.
Next, in your theory, your caterpillar theory,
Yes.
you have the effective you have the area where the two spheres meet as a variable. However, in actual paper, it is a porous medium, so not all graphite particles will be actually in touch with each other, and there will be some discontinuities. How did you consider this in your so-called caterpillar theory?
Yes, because I also observed that for myself with my SEM photo analysis. However, I took this as a control variable and eradicated it as much as possible by drawing it 500 times and then using the HTML color.
Right, okay. Next, I'd like to ask you some more specific questions about your experiments. So what is the resolution of your voltage and current measurements?
What
And
do you
your
mean
resistance
resolution?
measurements. So the minimal, for example, it'll be what, 0.01 ohms, or what's the resolution of your measurements?
I don't get by resolution. Can you clarify, please?
I'll be asking that later on too. And next, what is the minimal length you could measure of the pencil that you have mentioned when you have applied the conservation of volume?
Of the minimal, which length are you talking about? The height of the line or the height of the
Okay, the opponent, please take a moment to take the floor. opponents, you have the floor.
This is Jim Keeley of Team Format of Hannah Academy Seoul, and I'll be the reporter. I'll be the opposition for problem number 10, conducting lines. Right. So the problem statement, as you've seen, is to investigate the characteristics of a line drawn with pencil on paper. Here's the report overview of the reporter. The key point of his report was a so-called caterpillar model, which he used to simplify the situation extremely. Also, he has determined all relevant parameters experimentally purely. Also, for his theoretical approach, he approximated the graphite line as a unit of spherical units, and he has calculated the line height from the conservation of volume from drawing the line with a pencil on paper. Next, for his experimental approach, he used a scanning electron microscope to observe visually the lines drawn. Also, he used HTML colors and RGB values to experimentally control his colors. Also, he used a multimeter to actually measure the current, as the IV response of the material was not ohmic. Next are the strengths and weaknesses of the reporter. The strengths are as follows. First, he used a mathematical approach to overcome the various limits that you might have analyzing the situation fully in a so-called caterpillar model. Also, he has considered some main parameters such as temperature and the radius of curvature for his model. Next are his weak points. He has ignored pressure that can have an effect on the graphite line and has only considered force. And also, he did not mention the exact condition of the line to conduct electricity. Also, he had poor experimental data matching for a theory that is based purely on experiments and experimental values and data fitting and matching. Next are some discussion points I'd like to go over. First, for the experiments, I'd like to know mainly about the actual measurements he used to develop his theory. Also, I'd like to know his statistical reasoning and data point and regression R-square values. Next, for the theory, I'd like to know the effect of paper as a non-porous media, as he has approximated his theory into a fully continuous so-called caterpillar. Also, I'd like to know the role of the non-homogeneous mixture and the role of the fillers, the non-conducting fillers it has on the phenomenon. Finally, in the theory matching with experiment, his entire theory was based on 3 experimental parameters. I believe that these parameters affected the accuracies and the result of his theory and experiments greatly. Therefore, I believe it is necessary for us to revisit his experiments and how they may affect its error rates in his presentation. Now I'd like to invite the reporter up to stage.
All right, thank you.
Okay, first of all, let's begin with the experiments. So you have mentioned that you have controlled the thickness of the pencil trace with the conservation of volume, correct?
That is correct.
And you have ignored, so when you draw a line with a pencil on paper, compaction may occur, and you have mainly attributed that compaction to force, right?
Yes.
And did you actually consider the role of pressure and the role of pressure that might have in this situation?
Yes.
And could you describe to us exactly what pressure was involved here and how that might affect the conservation of volume?
All right. Are you asking about the pressure I used during my first experiment?
Just in your first experiment and in your further experiments where you actually measured the 3 parameters you have decided.
I don't understand what you mean by I didn't measure pressure, but I did measure force, because if you divide it by the area, it's just...
And what is the area and what is the effective force then? It just give us the rough scale and the order of magnitude.
It was 121 centimeters squared.
Okay. So newtons per centimeter squared, correct?
Yes.
And do you not believe that those high pressures, due to the small surface area, that compaction may occur due to the high pressure involved?
Yes, because that can be explained with my appendix number 7. Please, go to my appendix 7, please. All right. Okay. So actually, can you go to my PPT, please? All right. So I actually conducted many literature reviews, and one of them suggested that the compaction of the graphite line can affect the conductivity. Now, this is one of my literature reviews, and you see those samples right over here, CC110, CC20 to CC50.
I see. Okay, I think we've seen enough. I think we got your point.
No, because this was 50 megapascals,
okay.
which is
so
not
I think
close.
due to time, I think we'll move on. Next, I'd like my presentation back up. Also, next I'd like to ask you about the actual resolution of measurements. Because your theory is based purely upon experiments, the resolution and the accuracies of your measurements will be very important. So first of all, you apply the conservation of volume when you drew drew the trace with a pencil, right?
Yes.
And what is the minimum? What is your resolution of measurement when you measure the actual volume?
What do you mean by resolution?
So what is the minimum scale you can differ? So for example, with a ruler it might be 1 millimeter. And what did you use? And what is the scale?
Right, I just calculated. Yeah, because you can measure. You can measure by a 15 centimeter ruler.
Yes. And what is the resolution? So you use a normal ruler, so it would be 1 millimeter, correct?
Oh yes.
Okay.
So it's
Next, I'd like to
0.5
further know about the resolution of your electrical measurements. So what is the resolution of the resistance you measured?
What do you mean? It differed for every single line. I conducted many
No,
experiments.
I am asking about the apparatus you used for the experiments.
My apparatus?
Yes.
A multimeter.
Yes, and what is the resolution and the accuracies involved there?
You mean the accuracy of the experiment?
Yes.
Okay, so that one, it can be measured up to from 0 ohms all the way up to 2 mega ohms.
Okay, I see. And so that is the range, not the resolution.
Yes. I didn't check the resolution for that. I just assumed that it was good enough for my experiment.
Okay, that is a pretty big assumption, as I will revisit later. Next, I'd like to go over your theory, and could I have my slide back up, please? Next, in your theory, you do agree with me that the actual pencil lead is a non-homogeneous mixture, correct?
Yes, it has clay in
Okay.
it.
And you said you used a 6B lead, and could you describe to us just verbally, very briefly, the ratio of actual graphite to non-graphite failures?
The best I could got was 70% of graphite to 30%.
Right, so a 70 to 30 ratio is actually a pretty big ratio for you to actually make the assumption that the mixture is homogeneous. And in your Caterpillar theory,
I actually never made an assumption that I used a homogeneous pure graphite pencil. I considered it during my experiment model, and that can be explained with beta.
no, so the spheres you have used in your Caterpillar theory are all identical spheres, correct?
No, those are particles of the graphite pencil. not
Exactly,
pure
and you have assumed those are all identical.
Yes, of course.
Yes, and in the actual graphite lead and the graphite pencil trace is a non-homogeneous mixture with a differing ratio of different particles. So not all particles will be actually conducting. So how did you justify this in your theory?
Okay, so the particles are not just like one particle is graphite, another particle is clay. Those particles are actually huge at scale because those particles are a bunch of these graphite layers and clays and all these particles of the pencil together, which means that all those particles are identical in the composition and the size and everything else as well.
Okay, so however, exactly. So you have, as you have mentioned, this relative scale is huge when considering the actual mixture and the homogeneous mixture. So you have just mentioned the role and the scale of the mixtures is huge.
Yes.
Yes. Because of that reason, I believe that it is we cannot consider your theory as fully correct, and we believe that there will be some adjustments needed because the particles are not actually all are not homogeneous, and they are actually a mixture. So next, I'd like to go over. I'm sorry.
As I said before, I use a 6B pure graphite pencil to
It is
use
not
as
pure.
much as clay as possible.
You said it was not pure. It is 70-30.
Yes, because you cannot buy pure graphite.
And
From a pencil.
Exactly. So
Every pencil
I
has
would
paint.
exactly. So we would need to adjust that in your theory because in your theory you have assumed that it is a homogeneous mixture. Next, I'd like to go over the actual physical meaning of your fitting parameters. So you have three parameters. That was, if my memory is correct, large R, small r, and beta, correct?
That's correct.
Can I know how those parameters you have set are affected by the actual parameters you can control experimentally?
Okay, now since I told you that I'm gonna take those the spherical particles as a whole bunch of graphite layers, you have to calculate the length and the dimensions of spherical particles.
Yes, I do understand that, but so what do those actual lengths and the sizes mean physically to us, not in your model? What do they mean and what are they determined by?
Through my problem, we have solved for the value for a large R, small r, and beta. So if we apply those three numbers into that
yes, I think we all understand that.
any graphite drawn on pencil on any type of paper.
Yes, but what are those parameters actually determined by physically? Because you have made a theory, you have purely controlled the experiments, and you have found the parameters experimentally. So I think it is very necessary to us to actually qualitatively analyze what those parameters are determined by to us experimentally.
Okay, so the bridge the values of larger, smaller, and beta have a role in playing the bridge between the microscopic to the macroscopic scale. So for that bridge, the values for 10 to the negative 7 meters, 10 to the negative 6, and 0.97 were the most accurate.
So it is unclear to us experimentally what we need to control to actually change those parameters, correct? For example, the width or the thickness or the what have you.
No. Those are the microscopic parameters for that, which are determined with my experiment.
Exactly. So you have so you've translated the microscopic parameters into a macroscopic scale. However, you don't actually determine how those microscopic parameters are affected by the macroscopic scale. So there's somewhat of a discontinuity in your theory, I believe.
I'm not sure if you saw my. All of those macroscopic parameters are inside my equation.
Oh, yes, they're inside your equation, but I'm asking you, how do they actually translate to the macroscopic theory, not looking at the microscopic? Okay, next I'd like to move on finally into your theory matching experiments. So I'd like to know a bit more about the error rate. So I could see a R-square value of 0.96 something. Do you believe this is acceptable? Do you believe this is an acceptable value here?
Which experiment was that?
I believe it was a logarithmic graph.
Okay, so that was the beta function, right? The beta function was not for the macroscopic scale, it was for the microscopic calculation of beta.
Exactly. So we have to determine in your theory is based purely upon experiments. You do agree with me that your three values, your three parameters are based purely on experiments, correct?
Yes, because it is impossible to mathematically model the randomness of a paper.
Yes, so in other words, the accuracy of your theory and the applicability of your theory will be largely determined by your ability to actually calculate these individual three parameters accurately. So do you believe that your R-squared value is 0.96 and was enough to actually verify your theory like this?
That is exactly why I use the exact same graph, same exact equation, and same exact larger, smaller beta values for every single graph I showed you earlier.
Exactly.
So it's not determined by just one R-squared value.
In those every single graphs, you could see some experimental inaccuracies in the actual regression, and I believe an R-squared value of 0.96 is too low to actually be confident in your theory and to actually be able to determine your parameters. Also, you have fitted your data with you have done a linear regression with just a few data points. I could see one with 5 or 6 data points, and do you believe this is enough to actually determine the parameters, which is crucial?
Points. I almost always had more than 20 points. Oh, are you talking about the width experiment?
Yes, just in general. Do you believe that your experiment is enough to actually determine the parameters which are crucial to your theory?
Of course, I have error bars for every single experiment. I conducted it several times. I used the same graphite line. I used an HTML source code to calculate the RGB values for that. I've individually counted how many strokes I've done. I've calculated the average force.
Right, so you have tried your best, but I don't believe a R-square value 0.96 is meaningful academically in any way.
All right,
to actually regress the situation.
All right,
also,
I've never regressed the situation of calculating R, larger, smaller, beta using that 0.96. That was for the beta function of the R radius of curvature.
Exactly. You have regressed it to actually determine the function. Also, I'd like to move on to another part of your experiments in your
No, I did not do that. I did not do that.
You have regressed your data both linearly and in a log function.
No, I have not. Now, for the graphs you see, for the orange ones and the blue ones, those are the ones that I actually calculated larger, smaller, and beta for the same values.
Okay, I see. Next, do you think your minimum resolution of your experiments was enough to be confidently calculate your relevant parameters?
Well, that's how I conducted the experiment, so I'll have to say yes.
Okay,
that is the
we'll
best you can.
stop the discussion here. Now, the opponent, please take a moment to summarize your discussion with the reporter.
Thank you. The basis of the reporter's theory was a theory based upon a sort of a assumption. However, he has verified that assumption and used relevant parameters purely experimentally. So I believe that the accuracies of these relevant parameters will be extremely crucial to actually verifying his theory. However, there were several statistical limitations and experimental limitations we could clearly verify. Also, his theory could not actually explain the effect of paper as a porous media and the non-continuous pencil traces, as he had an assumption where the spheres were always meeting and they had a contact area. Excuse me. Also, he assumed that the mixture was homogeneous, and it could not explain the non-homogeneous mixture, which his experiment was a 70-30, as he has stated, mixture of graphite and fillers. So I believe that is a limitation of theory. Thank you.
Ladies and gentlemen, this is reviewer of Team Frisbee, this is Park, and I'll start some questions to both of teams.
Right.
First, reporter, do you know that the carbon particles will be attached to the paper as a shape of flake, not a sphere?
Oh yes, I just modeled those graphite lines with that. So the graphite line can be very complex and very like in the twirling motion and like all tangled to each other. However, I'm going to reorientate them by those caterpillars.
So do you think that another shape of the carbon particle can be applicable to your theoretical model?
Yes, of course. That is the reason for my modeling. That's the reason why it did, because the particles were too random.
Have you also considered to adapt some parameters, kind of Birmingham parameters that can calculate the randomness or the roughness of paper surfaces?
Yes, I took that into a control variable, so I did not.
So, have you considered the contact resistance of the ohmmeter of the measuring apparatus?
What do you mean the contact resistance?
Okay, so the contact resistance can be happen with which pressure you took or the which humidity you measure the electrical characteristics of conducting lines. So you may not consider the contact resistance. Is it right? Did you consider the effect of contact resistance?
Oh, like the wires and stuff. Of course, I didn't measure them. They were only near made to.
So you didn't consider?
I did consider. I measured it in my experimental apparatus.
Okay, thank you. And now, opponents, the reporter team suggested theoretical model with a sphere of each carbon particle. So, do you think that kinds of theoretical model can be justified, or alternative another kinds of microscopic theoretical model, or there cannot be a justified theoretical microscopic model?
I do believe a microscopic model is possible, but I believe there are some inaccuracies in his model.
And also, how do you think that the contact resistance can affect the whole entire result of the experiment?
Well, his theory was based entirely upon experiments. I do believe that the contact resistance and other experimental inaccuracies is a large part of one of his limitations.
And how you also pointed out about the resolution of the picture to calculate the RGB values, and why do you think that the resolution may change the RGB values or the bright of the colors?
No, it was not the resolution of the photos. It is the resolution of his actual meters, ammeters or ohmmeters and the such and rulers and whatever experiments he used.
Thank you. And also, the reporter team introduced beta as a parameter of area ratio, and why didn't you check or verify to measure the beta?
I did ask him whether always the particles would be in contact and whether that would change at all.
Thank you.
Okay. Reviewer, please take a moment. Okay, reviewer, you have the floor.
Hello, ladies and gentlemen. This is the reviewer Junseok Park from Team Red Frisbee, and now I start the review on problem number 10, conducting lines. The problem requires us to investigate the electrical characteristic of conducting lines, and now I will summarize the whole report of the reporter team. First, they made some theoretical models. Sorry for the delay of the presentation. And there was some theoretical progression with talking about connection between the micro and macroscopic theoretical model, and there was also theoretical background of graphite structure. And there was also a mathematical modeling for the conducting lines and formulation of the resistance. And in experimental progression, they made a drawing machine, and line thickness is control variable, and also they measured the resistance versus the force, length, wise, or another characteristics of conducting lines. And the reporter made a various and creative selection of parameters, and also there was a microscopic approach of qualification, and also informative PPT, but oversimplified and not testified theory was supported, and also there was a non-consistent experiment control or any kinds of statistical evidence for curve fitting. So we agree with the model was used in the research, but there was a rough model and oversimplification for the conducting lines and non-continuous pencil trace. About the opponent, there was good summary report and sharp evaluation of experimental setup, and they pointed out many flaws, and the experimental data's evidence or they covered most of the flaws, and they pointed out some missed experiments, but they didn't understand the composition of the pencil lead is also considered in their microscopic theoretical model, and they repeated some minor details of experimental methodologies, and they didn't explain about the reason why microscopic model can't be justified. So there was some discussion about the thickness of pencil line, and without that, also the pressure which was controlled in experimental procedure can affect the amount of graphite that gets rubbed of the pencil lead due to the mechanism of pencil line happening, which is called as a guard-wear mechanism. And also there was a mention about the resolution of multimeter, and they didn't check about the uncertainty of measuring apparatus, and we also agree that resolution or the uncertainty of measuring apparatus can be also verified. And the pencil is a non-homogeneous mixture, so we also need the reporter team should have checked the consistency in the composition of the particles such as EDS analysis. And the opponent also asked about the parameter meaning, and the bridge between microscopic theoretical model wasn't as simple as a few parameters that can make an expression about the experiment. Also, there was some values about statistic figures such as R-square value, and we also thought that they should have tried different equations to see if there is a better fitting plot. And there was also a mention about data points. And we think that the contact resistance between multimeter tip and conducting lines should have been considered, and the humidity or the rough and oversimplified model needs to be also justified. And the water tank for the weight can be evaporation, so we think there should be additional thoughts such as this. Thanks for listening.
Okay. The reporter, please take a small minute to make your final concluding remarks.
Alright, I would like to thank the opponent and the reviewer for such constructive feedback. I really appreciate it. Now, I wanted to go over some of the points that we all didn't understand quite very right. Now, my theoretical model was not modeling the individual atom of graphite or the individual atom of clay. My theoretical model was to gather the bunch of graphite layers to see those as a particle, as a spherical particle, and to see how those particles can be modeled into the macroscopic level. Now, they mentioned that I lacked statistical evidence. But did I? Every single experiment I had, it had a consistent value of large r, small r, and beta. Large r was 10 to the negative 7th meters, small r was 10 to the negative 6 meters, no, sorry, the other way around, and beta was 0.97 for every single experiment that I did. So the statistical evidence for the beta function, yes, that can be an issue if the r squared for 0.621 is not enough. However, my model can, with those quantitative analysis of the small radii of this large r, small r, and beta, my model can predict any other graphite line that we can draw on paper and any type of paper in that fact. Thank you.
All right, I'd like to thank all three teams. Now the jurors will ask you some simple questions.
I want to ask a question to the reporter.
Yes?
What do you think is the relation between the total number of atoms and the light absorption of the line?
The length of the line?
Light absorption of the line.
The line?
The darkness of the line.
Oh,
this
the darkness.
is scientifically light absorption by the light.
Okay, so how graphite is deposited on the line is the van der Waals bonds between those layers are broken. So
I'm asking the relation between the total number of carbons in the line and the light absorption by the line.
The RGB values?
You can translate that.
Oh, okay. So the RGB values, if they were darker, it means that there's more carbon. And in my experience,
So is it linear, quadratic, or exponential? Well, what is the relation between the total number of atoms, carbon atoms, and the darkness of the line?
It just increases the height of my line, so the number of caterpillar rods.
So you're saying that it's linear?
I don't know to what extent the rate of increase for the line is though.
Then what is the relation between the total number of carbon atoms in the line and the number of imaginary caterpillar rods?
Oh, that can be modeled with my floor function. I changed my the macroscopic level, the area A, and the length of the line to, and divided it by my larger values.
So what is the relation based on your model? Is it linear relation or quadratic?
So yeah, it's just linear relation for the length of the line and an inverse.
So you're based on your model, the total number of carbon atoms and the number of caterpillar rods, which has linear relationship with the currents that's flowing through, has linear relation. So is that your model?
Because whether if it's a linear relationship or quadratic relationship doesn't matter. All we have to do is like to measure the how much of an accuracy can be modeled into a rectangular prism model, which consists of values 7, regardless of the height or the length.
Okay, so the second question is that you used a multimeter because the carbon line did not follow the Ohm's law. Then what do you think the multimeter is using? What physical principle does the multimeter use to measure the resistance?
It uses other resistances to, it has like an internal resistance, and then they use like the ratio between those two to calculate the resistance for that.
So do you think that the multimeter is not using the ohmic law to calculate the resistance and show it to you?
Oh, it does use it. It uses a current and a voltage. However, it's consistent for every single time compared to if we change the voltage ourselves. So that's a point I took into the control variable. But yes, the multimeter also uses current and voltage.
Okay, thank you.
I have one question for the opponent. You raised an issue about the IV measurement, but I remember that you didn't draw this issue on the discussion. So could you explain why you think that the IV characteristic or IV measurement should be addressed?
So IV. Oh yes. First of all, thank you for the question. And I believe that we are investigating an electrical property, and he has already stated that it is non-ohmic, so it doesn't follow Ohm's law. So if it doesn't follow Ohm's law, the main electrical characteristics we can draw from this is actually the IV characteristics. So I believe it is crucial for us to investigate it.
But if you thought about that, then why did you start and initiate this discussion with a reporter? Is there any reason that you didn't do any discussion about that?
I believe that is somewhat of an oversight by me because I assumed that the multimeter readings were correct. But revisiting my line of thinking, I believe there might have been some inaccuracies in that.
Yeah, I'm gonna keep following the same path. You've brought up very non-germane points. And the first graph that they showed is very nice. I don't think not many people would do the IV characteristic. So, without even asking about the resolution of their multimeter, how did they define resistance? How did they measure resistance? Because I'm assuming since you didn't ask him, and he was not clear how resistance was defined in his presentation, so I'm assuming that you fully understand how he defined resistance. So exactly how the resistance that he reported, how was it measured?
So are you asking me experimentally how he measured the resistance of the pencil trace?
I'm asking how he did it because you didn't ask him and it wasn't very clear, so I'm assuming that you know. So how did he measure resistance?
Experimentally, he has mentioned that he used a multimeter to measure it, and I believe there might have been some inaccuracies in that process.
So you just plugged in a multimeter and just read the ohms? He was careful enough to do a IV characteristic.
Well,
right. So he has a way to source voltage and measure current. Right.
Well,
so did he just put ohms on the DMM and measure ohms?
Well, in the beginning of his presentation, he has actually looked at the IV characteristic and shown that it was non-ohmic, so he can't use a normal analog.
But you didn't ask that. You asked the resolution of their equipment, but you didn't ask the most fundamental question. So I'm assuming that you know exactly how he measured resistance.
Yes, I do believe there's somewhat of an oversight to me that assumed that his methodology and his multimeters.
Reviewer, right? So you went. So how did they define resistance on a non-ohmic material?
Excuse me, non-ohmic material.
They showed it's clearly a non-ohmic material. So how did they define resistance?
I believe that the basic principle or the mechanism that multimeter operates on this measurement is that ohmmeter creates a little magnitude of the of electric currents to the pencil lines, then we can maybe measure the decrease or the reduction of the voltage between two conducting lines, but they even didn't consider about the contact resistance, and they didn't use a four-point method to calculate the resistance between two conducting lines. So we believe that the measuring method has a critical error in their experimental method.
And you guys talked about their caterpillar model. Is there any part of the model that might explain their non-ohmic behavior of the graphite? And why was that mentioned in your opponent's discussion with the reporter? Opponent? I mean, is it obvious to you that this is non-ohmic?
Excuse me?
Was it obvious to you that the material was non-ohmic material? That's why you didn't even ask.
Well, my line of questioning to him on how he actually considered the non-continuous material and why his so-called caterpillar model was modeled as a chain of continuous, continuous materials was aimed at that direction, I believe.
So did you answer my question?
I believe that yes, that is the purpose of my line of questioning to him.
No, did you answer my question?
I'm not quite sure, but what do you mean?
My question was, what in their theory would explain for non-ohmic behavior?
What part of his theory? So I believe that his theory cannot explain anomalic behavior, and that is the reason why I asked him about non-continuous.
But you asked him about the resolution of his equipment.
Well, that was another line of questioning from me to actually question
Okay,
his.
reporter, please settle this question. How did you define resistance?
Resistance, I first tried to measure it by the charge density, and since conductivity is proportional to the electrical field, I tried to measure that, but I couldn't, so I tried to use...
Alright, let's make this quick. The resistance that you showed on your graph, right?
Yes.
How was that measured?
It was compared with the IV current and with the multimeter readings.
So you biased the current and measured the voltage, or biased the voltage and measured the current? Which way?
I varied the voltage for the IV current one.
So your resistance is a differential resistance?
I beg your pardon?
So the resistance could be defined in many ways. It could be the slope of the IV curve, right?
Yes,
so
yes,
you have
yes.
so you have a nonlinear IV curve. So is it the slope at certain point of a bias that you reported?
Oh yeah, that is the case for the IV graph. It's the reciprocal of the...
I'm just asking for the resistance values that you pretty much showed the rest of your graphs.
Yes.
How did you come up? How did you read that value?
With the multimeter readings and compared with...
And then you did the experiment completely wrong then. And okay. Okay, scores for the reporting team. We have a 5, 6, 7, 7, 9, 7, 7, 7, 5, 7, 5, 6, 6, 7, 7, 6, 6, 4, 3, 6, and a 4. The opponent team. Eight, 6, 6, 4, 6, 7, 6, 5, 7, 7, 6, 6, 3, 6, 9, 7, 8, 8, 7, 6, and a big 2 from me, which I think was generous. Scores for the reviewer team: 6, 6, 6, a 7 and a 5, 7, 7, 6, 7, 8, 6, 7, 6, 7, 6, 6, 8, 7, 6, 7, and a 4. Okay. All right, I'd like to thank all three teams for a beautiful 1 hour that I will never get back. And we'll take a 5-minute break.
시험하겠습니다. 하나, 둘, 셋. 마이크를 시험하겠습니다.
나 완전 착하지? 내가 완전 착한 것 같다고? 누구? 이거 어떻게?
이거 껐다 키면 플래시가 그만이
I분의 DV를 측정하면 I분의 V를 측정하면 그걸 짚고 그리고 쇼케이션 일단 솔직히 왜 그러냐면 저걸 눈 오믹이라고 말하는 순간 레지스턴스의 정의가 눈 오믹이라고 말하는 순간 재능이 근데 그걸 여쭤보고 어제 우리 갔을 때 그 얘기를 아이비 얘기를 하나 론 오믹이라고 하는 순간 어플라이드 된 볼테이지에 따라서 레지스턴스 값이 밝혀지는데 넌 레지스턴스는 뭐지? 그러니까 정해야 되는데 달라지 의미가 없어
와이추의 레지스턴스 정의가 그런
다이오드처럼 나온다는 거잖아. 의미가 없죠. 근데 그러니까 다이오드에서도 디퍼런셜은 그래도 의미가 있는 거야. 둘 다 몰라. 난 모르겠을 거야.
여기서 만약 포맷이 컬링타워를 찍는다면 충분히 가능하지. 발표를 그래도 못 받았으니까 괜찮아. 형우요. 음식도 못 받고. 따라와.
아니다.
다시요?
네.
진짜 일어나. 봐야지. 이제 일어나. 사진 도장 내가.
All right, if I could ask everybody to be seated and be present and soon start. Okay, reporting team, you're free to start, take the floor and start whenever you're ready.
Now. Good morning, ladies and gentlemen. My name is Man Young-han from Team Format in Han Academy Seoul, and today I'm going to talk about problem number 14, the falling tower. Here's the problem statement. As you look at the problem statement, it didn't mention exactly how the identical disks are stacked. So before starting, I'm going to talk about how our team thought about the criteria and parameters for this problem. And this is the situation. And finally, it is asking for the conditions we intensively mentioned about it. First of all, I'm going to talk about how our team divided the main parameters to 4. First, we consider the properties of the identical disk, such as the radius, height, mass, and coefficient of the friction. We also consider about the condition of the floor, the method giving the sudden horizontal force, and also the number of the disk. And as you can see in the video, all parameters should be considered in this phenomenon. Here's the flow chart. First, I'm going to talk about how our team set up the experiment, and after that, the basic phenomena observation. After that, I'm going to talk about the analysis of this phenomenon, divided in 4 steps, and end up with the conclusion. This is the device we used in our experiment. Using this device, we can control and apply the sudden horizontal force. And as you can see the video on the screen, it applies a sudden horizontal force. Before to investigate the condition for falling tower to remain standing, first, we investigate the movement of the disk when the sudden horizontal force is applied, and after that, we consider the standing condition. Also, since the problem statement was too complicated motion, we started the investigation with 2-disk model. Before the actual analysis, I'm going to talk about how our team divided this complicated situation in 4 steps. First is the parallel movement, second is the rotation movement, third is the free fall, and the last one is the rearrangement. The first step, parallel movement, works is until the total center of mass of the disk above the lowest disk get out of the boundary of the first disk. And in this situation, the only forces make the movement is the friction. The second step, rotation movement, works is until the left down edge of the second disk gets out of the boundary of the first disk. In this case, the gravity, normal force, friction makes the movement. In the third step, free fall works is until the right down edge of the second disk meets the floor. In this case, the only forces make the movement is the gravity. Finally, the rearrangement has something special characteristic. It has a collision between the floor and second disk, and also the collision between the disk in that falling tower, and it has a translational rotational movement. Also, we had this data from our observation, and this is the AT graph from the bottom disk. And as you can see, after applying the horizon force, after 3 seconds, it has a constant velocity. Therefore, we thought that the force is given for a really short time. First, let's think about the 2-disk model, the first step, parallel movement. In this case, the only forces that makes the movement of the disk is the friction. However, since we do not know whether this friction is static friction or the kinetic friction, we divide it by the situation. The static forces works until the maximum static forces of the friction is smaller than, so therefore we divide it to static and kinetic. And this is the equation for this. Now let's move on to the second step, the rotation movement. These are the forces that the second disk gets. And also, in this situation, we set up the phi function, x, y, zeta, n, and I. The reason why we set up the phi function is the rotational inertia and normal forces is not a constant value, and it is a function of time. Therefore, we first use the force equation and torque equation like this. And since to calculate the rotational inertia, we use the parallel axis theory, and the rotational inertia could be just like this. Finally, we use the geometrical properties such as like this. We set up the coordinate system where the origin point is the edge of the right of the first disk, and we can induce the equation like that. Now let's move on to the statutory freefall. In this case, the only forces that is applied to the second disk is gravity, since there is no friction and no normal force. So we can thought about the xt, yt, zeta, t graph, such as the constant velocity, constant acceleration, and the constant angular velocity, and we can induce the equation like this. Finally, let's move on to the last step, rearrangement. In this case, we need one important assumption that there's no bouncing movement during the collision. And if opponent wants justification of this, I'm going to talk this later. And also, focusing on the normal force, actually the normal force graph of the FT graph will be like this. However, since the collision time is really short and it is hard to calculate, we use the average force. Therefore, we use the average normal force during the calculation of the rearrangement state. This is the equation for the rearrangement part, the x, y, and zeta, and we use the friction, normal force, and torque for this situation. This is the experimental result. As you can see on the video, this video is the result from when the basic condition is at the right side. And as you can see, the red line and blue line is each representing the initial displacement and the final displacement. And as you can see, the error rate is 3.97%, and it makes the validity of our theory. The left side and right side graph are each the average deposition time graph of the x-axis and y-axis when we had the experiment average on these 20 times. And in this situation, since the parallel movement is more important than perpendicular movement, let's focus on the left graph. The right side graph is the simulation graph from the theory, and as you can see, since the value of the R-square is 0.981, there is a good agreement between my theory and the experiment. We also calculated the step switch timing comparison. The line of the red and blue is each from the experiment and the theory. And since the maximum error rate was 3.91%, there is a good agreement between the theory and experiment. Next, let's move on to Andes model using the basic idea from two-disk model. First, let's move on to the parallel movement. Before starting the actual analysis, here's one theory to think easier this phenomenon. When the k plus 1 and k between that term should be the start of this slipping, then the lower side couldn't be the kinetic friction since it has a constant value. So the conclusion for this is the upper side blocks can start slipping only when the lower side has a friction called it static friction. Also, we had calculated the sequence, and since you can look at this inequality, the n disk moves it first, and after that, the n-1 disk moves, and there is a sequence like this. And this is the average sketch of the graph. And as you can see, there's a sequence from the top of the disk and to the second disk in the kinetic friction in the sequence. And this is the equation from the two-disk model as I showed you before. And using this, we can calculate the xt graph from the position that depends on time from the all static, and before the disk k have the kinetic friction, and the after disk k have the kinetic friction. Let's move on to the second step, the rotation movement. As I did similar way at the two-disk model, we can set up the function about the 3 and -2, and this is the force that is induced to this falling tower. And we can also induce the equation using the force equation and torque equation like that. And as I showed you before at the two-disk model, this is the geometrical properties as I showed you in two-disk model. And using this, we can also calculate the geometrical properties in n-disk model and set up the equation like that. Let's move on to the search static freefall. There's actually no big difference in three-disk model. There's only the gravity. Gravity is only the applied forces to the two-disk model. And also there is no normal forces and no friction, and we can calculate the x, y, zeta using the constant velocity, constant acceleration, and constant angular velocity. Let's move on to final step, rearrangement. As I showed you, we need one assumption that there is no bouncing movement during the collision. And also focusing on the normal force using the average normal force, there is a step like this. Actually, at the two-disk model, there is only the one case. However, since in the n-disk model, the force applied to the bottom disk and top disk were different, when differentiated with the k disk, this k, we have calculated this all differently. this is the experiment result from the Andes model, and there's a sixth disk in this situation. And the basic condition is like that, and as I showed you before, the red line and blue line is each representing the initial and the final displacement. And this is the result of the situation. And the average error rate was 4.21%, and as you can see, there is a good arrangement between my theory and experiment. And the left side is the graph from the experiment, and right side is graph from the theory. And also, as you can see, there is a great agreement between the theory and experiment, checking the magnitude of the Earth sphere 0.977. We also considered about the main cause of the error, and we thought the main cause of the error was because of the difference of the coefficient of the friction between that disk. If there is a difference in the coefficient, then the condition to make the kinetic friction could be different, and the consecutive properties couldn't work in this situation. Therefore, in this case, my theory could not be applied in this situation too. And finally, let's move on to the condition for standing. The basic mechanism is really simple. When the total center of mass above the disk case is inside the boundary of the disk case, and it is stable condition for standing. However, when the total disk is outside of the boundary of the disk case, then this is the situation when the condition for the standing is not stable. Using this calculation from the disk and to disk 2, we can have kind of the algorithm flow chart like this. When we give the basic condition to this, then it calculates the movement of the disk as I showed you, using the formula as I showed you before, and through pass of this conditional statement, and finally we can determine whether it is the condition for stable or not. And this is the example for my theory as I showed you before, the algorithm flow chart. The left side and right side has each different basic condition, and left side is the difference of this condition is the horizontal force. And calculating this from my theory, there's an expectation. Each of this is the remain standing and not remain standing. And this is the video from the actual situation, and there's a good agreement between the calculation and experiment. I'll end with my conclusion finally. The problem statement was keep asking about to investigate the phenomenon and also determine the conditions that allow the tower to remain standing. For the investigation, our team divided this complicated phenomenon on four steps: parallel movement, rotation movement, free fall, and rearrangement. And we also calculated the movement of the two-disk model and Andes model, and also thought about the main cause of the error. For the experiment, we had these kinds of the four parameters like this, and we also considered about the conditions for remain standing in this falling tower phenomenon. And this is the reference, and thank you for listening.
Okay, opponent, you're free to ask questions to the report.
So first of all, I know that you addressed in your PPT, but again, what are the variables that determine the condition for standing in your presentation?
As I showed you before, there are a lot of parameters I used, and in the experiment, I changed about the 7 parameters.
So where is your experimental data?
Could you ask me one more time?
So what you did is you matched the theory and your simulation data, but
yes.
I'm not seeing any photos or evidence that you have conducted actual experiments with the actual blocks by changing the parameters.
Actually, changing all of the parameters in one situation is impossible for the experiment. So we have the initial condition like this, the basic experiment condition, and we have the differences about the one by one parameters.
I'm seeing that the apparatus that you hit, all the photos that apparatus, I think that is different from your original experimental apparatus. Is that correct? Is that the same machine?
Yeah, that's right.
So are you hitting that with the motors?
Yeah, this kind of the device we use.
I'm seeing that the two brackets are holding the bottom hitting,
yes.
But in the image.
Yeah. So you're talking about there is no that type, right?
Can I see the image before the one you showed the hitting the blocks? Can I see where you have the block tower?
So I think you're talking about the.
Yes, that apparatus. Is that apparatus the same thing as the apparatus you showed right before?
Yeah.
But it does not look the same. So do you have your code for your simulation provided?
So in the code.
So you said you conducted a simulation.
Yeah.
So was that done with a program or?
Oh no, just for the calculation algorithm flowchart.
Okay. I think that is it for now.
Thanks.
Okay, opponent, you have a couple of minutes to prepare to take the floor. Okay, opponent, you have the floor. Please lead the discussion with the reporter team.
I'm Edward Choi from Team Frisbee, here to start the opposition on falling tower. So, the main key points of the problem was about using the identical discs, applying sudden horizontal force, and the conditions for the tower to remain standing. So here's the overall summary. The problem definition and the observing of the standing and the falling, and there are some variable setups that can determine the conditions for standing, and the experiment and the conclusion. So the strengths are that they divided the dynamic motion step by step for the falling, and they applied force analysis on each of the discs. But here are the points of improvement. The variables that were not considered on the actual experiment, and the lack of experimental setup, and the inconsideration about the coefficient of restitution by assuming that the restitution coefficient was 0, and the friction coefficient and the other factors that can happen on the phenomenon. Here are the discussion points. So, first of all, I would like to discuss on the errors about the preliminary experiment setup. And for the second discussion point, I would like to talk about the horizontal displacements of disks happening during the sliding phase. Additional explanation has to be done on that. And for the third discussion point, it was about there could be cases where before the first block slides out entirely from the overall tower, the second tower might hit the floor. So there should be more considerations about various situations. And for the direction of normal force in the rotating phase, we think that the direction of the normal force was indicated in the wrong direction in the presentation slide. And for the fifth discussion point is about the verification of the assumption that there's no bouncing, because in the video in slide 27, we have observed the bouncing. And number 6 is about the impact force exerted on the tower if the constitute of restitution is 0, because we believe that the impact force exerted when the overall tower collides to the ground cannot be neglected. And for the discussion point 7, there has to be a detailed explanation of how the simulation graph was plotted. And for the eighth discussion point, there has to be a clarification on the necessity of the friction of the block tower to be a static friction so that the disk can slip. And for the 9th discussion point, it is about when the conversion from the static friction to the kinetic friction is occurring. For the 10th discussion point, we need visual evidence of the experiment setup and the hitting apparatus. And for the 11th, we're not seeing a clear correlation between the experiment and theory and the experiment result. It lacks an explanation. And for discussion point 12, we need to discuss about the correlation between the simulation and the real-life conditions. Discussion point 13 is about the actual code used for the simulation. I think we needed this data to be provided. And for discussion point 14, there are variables that are not covered with the experimentation. And for the 15th discussion point, there has to be numerical data obtained from the experiment, but I mean specific quantitative conditions that determine the tower to stand or fall. And that is it. Thank you. I would now like to invite the reporter to discussion. So I would like you, reporter, to state the conditions of the tower to stand clear and briefly.
So you're talking about the initial condition of the basic experiment?
That is true.
Can I show you this with the slide? Because there are lots of information in this. Actually, the slide is coming slowly, so I'm going to talk just. We changed basically the several parameters in the basic experiment. And we thought the main cause of the error was the difference of the coefficient of friction between the
I'm not talking about the errors. I'm talking about the exact conditions that determine the power, the standing and the falling.
So you're talking about the basic conditions for that? Actually, I told in my slide, as you can see.
How about this brief tendency? So for the experiment you conducted, such as the radius and height. So for the radius, what about the radius? So what do you think, a small radius or a big radius, which one is more likely to
So you're talking
stand?
about there is a critical point about the radius.
Yes.
When it is larger than the radius, then it will fall or remain.
So what do
like
you
that.
think? So a large radius or a small radius, which tower stands better?
We can determine just like that. We have to go through this algorithm flow chart since there is a lot of parameters.
For the force that your experimental setup exerts, is there numerical data that how much force does your experimental apparatus exert?
Yeah, we actually give the graph from the AT graph of the bottom disk, and actually.
So do you have
from
the exact number in that graph? Can we see that graph?
Yeah, you can see that. You can see this is the acceleration graph, and if you calculate the mass from this, then you can calculate the force.
So can I see your actual experiment data? So like the one where you use the actual blocks to hit.
So you're talking about the conditions.
So what is it that you actually conducted? So did you conduct a simulation using a computer program, or was the actual experiment conducted with the blocks?
We have the comparison between the experiment from our experiment data from our experiment and the calculation from the flowchart as I showed you in the algorithm.
Can we see our slide, please? Can we see, so can you tell us about the horizontal displacement of disks happening in the parallel movement phase? So what I mean is that as soon as the bottom disk starts to get removed, so in your setup, we observed a horizontal displacement happening between the blocks before the torque is exerted. So can you explain about this horizontal displacement happening?
So actually, what's your point for your question?
So my point is that you said that the horizontal displacement between the blocks happen in the initial phase. So can you explain about this?
Actually, in this case, the only forces. Actually, in this case, this is the phenomenon. As I told you, this is a step 1 parallel movement. In this case, the only forces this gas is the friction, right?
That is correct. So can you do a force analysis to determine. So for example, for a 3-block tower. So can you start writing the forces so to see the sliding?
We thought that the basic forces here is applied only to 5.
Can we focus on the horizontal forces? So are we assuming that the bottom block receives a constant force?
So when the bottom this is applied the southern horizontal force, then there will be a friction too from the bottom and the top, right?
So let's assume that the mass of each block is m.
Yep.
So is this what you're assuming?
No, this is the only case when the kinetic friction works. However, since I told you before in my step 1, the parallel movement, there is a static friction and the coefficient and the kinetic friction. There's a separated the part.
So can we see the numerical data for your experiment? For example, at what radius and what height the tower fall, and in what radius and what height the tower stand? Can we see the data?
I think you talked the same question before. There's no actually the condition for only the one parameters. All of the parameters, the 7 I get in this experiment works together.
How did you conduct the simulation?
So you're talking about the code?
Yes.
Actually, the calculation for the algorithm flowchart was the formula for that, and actually going through this, passing through all of the conditional statement after that, then we can determine whether it is standing or not.
So I'm asking this again and again. Do you have a numerical data for each setup of your tower? I believe that you change each variables and control the other variables. So do you have data? So such as.
So you're talking about how I calculated the simulation, right?
So for example, when there are like 5 blocks with 5 centimeters and 1 centimeter height, it falls. So that kind of experiment.
So for the simulation, we use the Mathematica for that, and we use basically to solve the differential equation, we use the anti-solve and differential equation for that.
So I want the actual number data. Do you have it?
No, actually not in this slide.
So you don't have a number data?
Number data for what? The condition of the result.
So do you think that the critical conditions for the tower for stand to fall can be expressed perfectly with theory?
Yeah, that's right.
Perfectly with theory. Well, do you have, so what I wanted to see was the numerical data in your actual experiment, so that if the forces between.
So I keep talking about that. So
you keep talking about it, but we're not. That doesn't mean that we're seeing numerical data.
Since this is actually the numerical data for that.
So that shows.
That
just shows the displacement change, but I wanted to see the condition for the standing and the falling for each radius and height value. So do you have it included in your presentation?
No, sorry for that.
So with that, we have no idea how you change the variables, how you control the variables for your actual experiment.
Okay,
and just by showing a simulation graph and telling that it matches your theory, and
so in the problem statement is asking for the condition for standing or not. That's right.
That is correct.
Yeah, but however you keep asking about the numerical value, but the standing or not is just a question of yes or no. So I think you are asking for the wrong question for just my problem.
Okay, I would like to see in your presentation where you're moving from the rotating, so the rotation part.
Or at this model to this model.
I want to see like the initial part where you explain the rotation.
Okay, I think you're talking about this.
No. Yeah. So the theoretical model explaining the rotation equations.
Okay, the rotation movement. Here.
So about the theta value that you're talking about, how is that able to be calculated?
Theta is the function of the time, and for the experiment we have the calculate just for the visually, and after that for the simulation we have the function of time, and after
So do
solving
you
the
have
differential equation
a
of time.
overall rough result experiments for the theta value, so the actual angle, how much is it?
Actual angle, and it was smaller than 5 degrees.
Smaller than 5 degrees. Well, wouldn't that depend on the actual experimental setup that you've conducted? The height and the radius and the
When
circle?
the height is really higher after than this one, then there will be a change of that.
How can you, like you said that you've conducted a numerical experiment with the actual setup, but again, if the force that you are using is not numerically expressed, then how can all these type of actual experiments with numerical data can be
The force
done?
that I applied it in this situation is only the external forces, and after that,
So
the
do you
calculation
have the actual number of the force that your repair is applied?
Yes, there is it.
Can you see that?
Here's the acceleration of the force I gave it.
So I mean,
The y-axis is the acceleration and the x-axis is the time.
So you said that in your presentation there is a point where the transition from the static friction to the kinetic friction is occurred. Am I correct?
So there's a situation, there's a point when the static changes to
In
the
what
kinetic.
point?
The point of the time.
So can you predict that point? So how can you predict the exact point where in the overall tower the transition from the static friction to the kinetic friction happens?
Okay, first of all, do you agree with there's a slipping motion that compared with the under one from the top to bottom? Do you agree with this?
So I think you keep going around and around missing the main point. I'm not seeing a clear explanation on the standing and the falling conditions of the overall tower. And what I'm asking was about the transition state for the static friction to the kinetic friction.
Yeah, this is the Andes model from the parallel movement, and as you can see, this is the basic sketch of the graph. And after the external forces is getting larger than the maximum static forces of the friction, then there is a translation of the static to the kinetic.
So with the simulation code that you have provided, when you insert the initial conditions numerically, can you determine if the tower can stand or fall?
Yeah, that's right. From the algorithm flowchart as I showed you.
So do you have the simulation results showing if it stands or falls?
Yeah, there is it. As I showed you in the example there.
Oops.
Here's something I want to talk to you. You keep asking about the wrong point of the problem statement. The problem statement is keep asking about whether they're standing or not. However, you keep asking about the numerical value. So what are you asking for the actual numerical value? The position of the x?
No, like the dimensions for the block.
As I told you in my presentation, the basic flowchart for this is...
Okay, opponent. Please summarize your discussion with the reporter.
Thank you. I'll start my conclusion. So the problem was mainly asking about the conditions for the tower to remain standing. Well, the opponent has tried simulations and said that he has compared it with the experiment, but overall we're not seeing any experimental data about the dimensions of the block and whether the block will fall or stand in that type of dimension. And the report thinks that the critical condition for the standing can be obtained completely by using the theory. But however, we're not seeing any empirical critical conditions, so I'm not seeing a clear correlation between the experiment and the overall theory. The report said that the report has considered many types of variables, but we're not seeing a clear example of how the variables were controlled. So overall, I cannot conclude that the reporter has successfully determined the conditions to remain standing. Thank you.
Okay, reviewer, feel free to ask questions to both the opponent and the reporting team.
So hello ladies and gentlemen, I'm here to review this whole thing, and I'm going to ask some questions to both of the reporter and the opponent. First of all, I'll ask a question to the reporter. And during the rotation phase, the second phase, the whole tower except for the first is rotating, and you were doing the torque analysis, and your pivot was the point of the contact, right?
Right.
And since the point of the contact is moving, did you consider the inertial force?
Yeah, that's right. And actually, I calculated using the parallelistic theory, and I calculated each different rotational inertia that depends on time function.
Rotational inertia as a time of a function you did consider. However, since the frame was non-inertial, you have to consider inertial force.
Inertial force?
Inertial force.
So I think you're talking about the torque equation I used, and about the rotational inertia, I calculated this as a function of time.
Not moment of inertia. I mean the force. The force since the frame is moving, frame is getting the force. You should calculate the force frame is getting to. You should extract it from the torque analysis, and you had to consider, and you didn't consider it, right?
I It's hard to listen to the point of your question.
Okay. Then, as the radius increased, how did the force of the condition of the force that makes the tower remain standing change?
As I told you to the opponent team too, the basic condition is critical for this phenomenon, and the result of the condition, whether it's standing or not, is perfectly result from the initial conditions. So when the initial condition is different, then we can only consider about the magnitude of the force.
As the radius increased, did the force needed to change to make the tower remain standing increase or decrease?
Partially increased.
Partially increased.
But only the partial, because as I told you, there is too much
Okay,
parameters I use.
then is there a graph on the PPT showing that?
No, I keep told you that there is a flow chart for the algorithm, right?
Yeah.
And after passing through all of the conditional statement, after that we can determine whether it is standing or not.
So
this is the numerical value.
Then do you think the condition for how to remain standing is determined by the center? Your job is to find the location of the center of force or to find the force.
We calculate the center of mass, the displacement of it using my theory, and
Okay,
after
time's
that.
up.
Okay, reviewer, please take a moment and be ready to take the floor. Reviewer, you now have the floor.
Hello, ladies and gentlemen. It is a great honor to participate in this wonderful debate as a reviewer of this debate. And I'm here to review the whole debate. And my name is Jae-won Dong from Hyundai. And let me briefly summarize the debate. And first of all, the reporter team showed the premises of such as definitions of identical disk sudden horizontal force, and secondly, he mentioned his model starting from the observation and starting from where n is 2 to n equals some k. And then he considered friction and torque as how friction and torque makes the displacement. And also he said he considered radius, height, and coefficient of friction. He experimented on, and moving on. And I will explain the strengths and weaknesses. And first of all, for the reporter, his strength is starting from N2, which is very intuitive, and he divided the whole process into 4 steps, which is very intuitive and very easy to understand. However, he had weaknesses such as his force was not very certain, because the 0.07 seconds was the total time of experiment, while the contact time was 0.01, and this is 15% of the whole time. And also, he had no graph of mass versus displacement, or the mass versus needed force to make it standing, or radius or some and other etc. which they should have done. And also for the opponents, they pointed out the numerous unclear parts about the presentation, and which is a very rigid point, valid point. And however, they had the weakness that they missed aspect of reference frame, or they failed to mention rotation while the freefall. So there were a few clash points, and first of all, the errors. The opponent asked question about the experimental setup, that there can be a lot of errors due to the and he doubted that the machine was actually used. And the reporter showed the graph at the bottom disk to confirm that they actually used the machines. And I agree with the opponent, because the impact time, even though they might have used the machine, the impact time was not very short enough. And the problem statement stated that it should be a sudden force. So they did not fulfill the problem statement, I believe. And then the second clash is that about the horizontal displacement. The opponent asked question, the condition for the tower to remain standing after the impact. And the reporter said friction and torque and some other forces. And I agree with the reporter, because displacement is made due to friction and torque, and they are the major factor that the displacement is made. And thirdly, the opponent asked they cannot rely on computer simulation and where all the numerical numbers, and the reporter wanted to show the tendencies through experiments. And I agree with the opponent, because the numerical value of stability condition is very crucial, because in this question our job was to find the condition. And also, the opponent said the simulation doesn't prove numerical values and inclusion of presentation. And the reporter said the condition for the standing does not need numerical values, and they also compared the graph. And the opponent asked the angle before the free fall affects the falling condition, and the reporter said it can be explained through the computer simulation. I agree with the opponent, because the rotation happens while the free fall. So these are the physics they failed to mention, because there is a rotation while the free fall. It is not completely free fall, but because of the torque previously acted by the first disk, there is a rotation. And also because of the non-inertial frame, and they did not understand the inertial force, however, there is.
Okay, we'd like to thank the reviewer. Reporting team, you have 2 minutes for your final concluding remarks.
Okay, ladies and gentlemen, I will end up this problem number 14, the falling tower, with the kind of the defense from the applied from the opponent and the reviewer. First of all, the opponent keep asking about the different experimental approaches. However, there was a difference on the experimental setup, just only on the angle of the camera, because to track the software of the auto tracks of the center of the mass, there need to be a clear background, and there's only the difference, only the just getting rid of the type, just only that. And also they keep asking about the numerical value. However, since the problem statement keeps asking about the conditions for whether it is standing or not, we have calculated with the theory numerically, and after that we have determined whether it is standing or not. So I think all of this was considered in my problem situation. And finally, I will end up with the conclusion one more time. Since the problem was asking about the investigation and the conditions for the investigation, we had the situation like they divided into 4 steps and calculated in the 2 disk and n-disk model. And after that, we had the conditions whether it is standing or not. And there was about the 4 parameters, and inside the first parameter there was about the 4. So finally, we have to use about the 7 parameters in this experiment. And that's all for my presentation. Thank you for listening.
Okay, I'd like to thank all 3 teams. We'll take a couple of minutes to ask questions to the teams.
Can you show me the presentation of the displacement of the second disk? So it's always positive there?
You're talking about this graph?
Yeah, this one. So when the first disk is heated, so heat, then in the first place, how the second disk move?
Wait.
How does the second disk move? it goes left or it goes right?
Oh yeah. Actually, it is different with the magnitude of the force. When the magnitude of the force is large enough to move the second disk, then the second disk firstly moves with the
Let's
static.
think about the friction. It's a friction to the second disk is a left hand side or right hand side.
Left side when the external force is given
So
to
then
the
the
left side.
displace must be negative, right?
Oh yeah.
But it's always positive. Why is that?
But this is the reason, since the sudden horizontal force is given in the sudden time, and after that you
But
don't have the
in your
acceleration.
experiment, it's not sudden. You push the first disk continuously.
That is the after the time in my presentation of the step 1. So before the step 1, there is the sudden horizontal force.
So it's before it starts with the heating, right? The time. Then the second disk must go left. So I don't understand why it's always positive.
I think you're asking about the magnitude of the acceleration. However, since we gave the acceleration using the device of the sudden horizontal force, after giving the force and after the step 1, the parallel movement, it has a rotation movement. So after parallel movement, first of all, it has the static friction, and after that, it changed to kinetic friction. So I think this graph works in my situation.
Can I ask some question to reviewer? Of course. So in the free falling process, the disk is rotating or not?
Yeah.
Rotating or not?
Rotating, yes.
Why?
Because since there is no force acting on it except for the gravity, for the rotation part, it only rotates when there is an omega because there is no alpha, right? But for the omega, since the first block have continuously acted the torque on the second disk and the older disk above, there is an omega which is non-zero, so it will have it will rotate, though it is not rotationally accelerated.
All right. How about that? The same question to the opponent. The question is, in free falling, the disk is rotating or not?
So you're asking, in the free falling, do I think that the rotation happens? Well, yes, I do. So
the reason is?
So the reason is that so when the overall center of mass of the other blocks, except for the bottom block, exits out of the bottom block, then the major force acting on the center of mass will be the torque applied. But as the bottom block is exited out totally, and then it's free falling, then I think it would rotate in the same consistent angular velocity, because right as it enters the free fall state, there is no torque applied.
I want to ask a question to the reporter. So what is the nature of the collision between the hitting rod and the bottom disk?
Actually, in the reality, there is a collision. However, we had the method to ignore this collision in our theory, and there was a two. So you're talking about.
So I'm asking if this is. Are you assuming this is a elastic collision or inelastic collision?
We thought that in the situation there is an inelastic collision.
Inelastic collision. Okay.
I have a question to the reviewer.
Yes.
So you mentioned about the question about the sudden force, right? In
Yes.
the problem statement. What is the exact definition of the sudden force? What's the time scale for such a case?
I believe the sudden force should the sudden force is quite vague terminology. However, for the clear topic, we should define it. And for me to define, I will define it as the force that contacts with the first disk with the time less than 10% of the whole timer process. And the whole timer process is defined as from the time when the first disk is getting hit to the time when all the motion is stopped. So yes, that will be my answer.
Okay, for reporters, Regarding the moments where the bottom disk is not completely removed, but the momentum transfer from the force is not completed, then you have to consider the force-induced torque. So I wonder whether you consider about that.
Yeah, we also consider about the situation, but since there was no enough slide, we also consider about the new step. So in my step, at the start step, there was a free fall. However, in this case, instead of this free fall, there's a new step. And the characteristic of this is there's a different forces that applied to the bottom disk, and the difference is there is a normal force and friction. And that's all, and I think there's no big difference about it. So the calculation method was similar to my method before.
Okay. For opponent and reviewers, do you think the bouncing effect is negligible or unavoidable?
Well, because of the lack of time, I didn't address the bouncing effect, but we do not think that it is negligible. Well, the bouncing depends on the material of the block itself and the material of the floor, but assuming that the coefficient of restitution is 0, I don't think that is the right application, and I think, most importantly, the actual experimental setup and the video has to be clearly shown for us to determine if the coefficient of restitution can be considered as 0.
For the second disk, it will collide with the floor. However, immediately after the collision with the floor, it will collide with the third floor, which is right above. So for the second disk, I don't think it will be crucial. I don't think the bouncing effect will be crucial to the displacement. However, for the topmost disk case, since it only bounces with the disk right under it, and it does not have, it has nothing to bounce on top of it. It will have the bouncing effect will have a crucial effect on its displacement. So while analyzing the displacement of the topmost disk, a bouncing effect is very crucial.
So to the reporter, what's the boundary between falling and standing?
So you're talking about the numerical value about it? Experimentally? As I told you before in my presentation, the basic method for determining the condition for standing or not is like this. When the total center of mass is outside of the boundary, we thought that it is not the stable condition for remain standing. So this is meaning actually the calculation is from the end disk and to the bottom disk, and at the end disk we only calculate the disk of the case only 1, and as we are thinking about from the disk K, then we are just calculating the total center of mass from the disk K plus 1 to disk K at the top of this disk. Yeah, calculated in where the initial condition is given for this situation.
I have a question. I think the debate between the opponent and the reporter kind of about exactly what's the most important parameter for this to be standing or falling. And I could just imagine if you had an infinite amount of material to make an infinite disk, or if you had an infinite sudden force, right? So which is more important?
So I think the most important parameters for the situation is the shape. So I mean the radius or the height. So the properties of the identical disk.
But if I had an infinite force just to evaporate the first disk, it should stand, right?
In this case, there will be a difference, right?
So which is more important, infinite force or infinite amount of mass on top?
As you're talking about that situation, then it could be the external forces could be more important than.
So you said yes to both, okay? All right. Okay, now the jurors will tally up the scores. Okay, well, first first, the scores for the reporting team. 8, 7, 8, 7, 7, 6, 8, 7, 8, 6, 4, 7, 7, 7, 6, 9, 6, 6, 9, and 5. Scores for the reviewer team. Opponent team, sorry. 8, 6, 6, 5, 4, 6, 5, 6, 6, 7, 7, 7, 3, 6, 7, 6, 7, 7, 7, 5, and 6. And finally, now the score for the reviewer team. 8, 6, 6, 5, 4, 7, 6, 6, 5, 9, 7, 7, 6, 5, 7, 7, 6, 5, 5, 6, and 5. Okay. Again, I'd like to thank all three teams and the audience for fascinating round of debates. And I wish you all a happy travels home.
인성. 그러면 얘가 여기 엔드 하면 되는 거야? 가서 물어보고 해.
베이식 언제부터 시작하는 거야? 뭐? 베이식은 언제부터?
몇 시? 그럼 여쭤볼게.
생기를 안 해. 몇 시에 오라고? 알지도 않아. 발표를 해야 되잖아.
제가 그 유튜브 끊으면 되는 거죠? 아니 죄송합니다. 저 유튜브 그거 라이브 스트리밍 하고 있었는데 저 그 KYPT 그 동호입니다. 그 유튜브 그 라이브 찍고 있는데 이제 끊으면 되죠. 죄송합니다. 잠시만요. 알겠습니다. 죄송합니다. 잘못 왔네.
라이브 끄는 거 몰라서?
이거 여기 있는 건가?
엔드 눌러.
아 혹시 뭐야 이거?
엔드 있어.